Good morning, everyone, and welcome to your penultimate HSMA teaching session. Dan, I'm wondering if you can just give me a quick shout just to confirm that the audio is working, because unfortunately my audio is being a little bit funny today. I haven't been able to get hyped up with the HSMA music as usual. So Dan, could you give me a shout, please?
Do you want a pay rise?
Well, if you're offering, that
Damn
sounds
it.
great.
I was hoping your audio was working. I didn't say anything. That wasn't me.
No, fantastic. No, well, that's great news. At least I can hear you, even if I can't hear the HSMA music. But that's a terrible shame that I'm in my usual kind of retro headspace. But we'll see what we can do as we go through the day. So, a little bit of housekeeping just before we kick off and get back into Streamlit. We're going through a load of advanced Streamlit today. I hope you'll really enjoy having the opportunity to learn some more ways to make your apps really fantastic, and also how to convert a discrete event simulation into a Streamlit app, which a lot of you I know are considering doing for your projects. On the subject of projects, project registration, I know we keep banging on about this, but it is very much coming up to the point of HSMA project time. We've got one more session next week, and then you are on to your project phase. Now, what I've put here sounds a little bit abrupt. No project registered equals no support. We need to be able to track what projects people are working on so that we can show basically return on our time, return on our investment in your skills. So what we really need you to do, no project too big, no project too small. If you're doing something that is an HSMA based project, something that you are using the skills you've learned on this course, please register it as a project. Just pop a message in the new project airlock channel, and we will register it as a project. You'll get a Slack channel, and you will be able to ask us questions. You'll be able to ask community questions, and we will make sure that you get the support you want to on your project. Whilst we recognize, we're not starting officially the projects for another couple of weeks. The sooner you register them, the better. And it doesn't have to be that you know exactly perfectly what you're going to be doing in every phase of that project. If you've got a solid idea of what you're going to do, and I know a lot of you have, we've had fantastic chats about some of the things you're planning to do, just get them registered, and we can help you. The refinement can still happen as time goes on. So on that subject as well, impact, you may have seen Dan has shared a Streamlit app that he has created to allow you to record various bits of impact. Dan, I don't know if you want to say a little bit about that, just kind of give them a quick overview of what that app is and how to use it.
Yeah, so thanks, Sammy. So basically, you've seen the app that I shared in the Central Plaza. This is really important. So basically, the idea is that, as Sammy said, our whole existence basically is the whole reason we do HSMA is to be able to demonstrate that we are making a real difference for health and social care and policing. And that means that we need to be able to track impact. So the first step is making sure your projects are registered, so we are aware of the work that you are doing, and that's vitally important. And secondly, we need to know about cool things that you have done as a result of that work. And so, as time goes on, hopefully the projects that you are doing will have real impact. They will, your model will be used to inform a decision that leads to X, Y, and Z, etc. But there'll also be all sorts of other impacts along the way. And this might be as small as things like, the other day in work, I used the skills that I learned on HSMA to do this cool thing in Python. Tell us about that. Okay, so it's very, very easy to do that in the app. All you need to do is go into the app, and there's a panel on the left called Impact Recorder. You just pop your name. It's already selected as HSMA, so keep that as HSMA. You can keep the month and year the same, unless you're reporting an old story and you want to sort of firm up the date. And then basically just quickly tell us what it is that you want to tell us. You're limited to 280 characters deliberately. We just need a very short summary. So think sort of old school Twitter, that you are basically just, telling us about something cool that you've done. And there's a box where you can put in a link if you want to link out to some more information or a GitHub repo or whatever it may be. But that's optional. And do submit that. It's really, really important that we are aware of anything that you're doing as a result of the HSMA program. And I can't understate that enough. I know we keep banging on about it. Our entire organisation, its entire reason for existence is promoting, making a real difference and causing research to cause change within the health service. And we are increasingly facing enormous pressure to demonstrate that we are having continuous impact. And I know that our team, and particularly HSMA is probably one of the most successful impact generation factories, if you like, within our organisation, and is generating a huge amount of change, but we need to make sure that we are capturing that. So literally it takes 60 seconds just to pop something on there. If you're at all in doubt, put it on there. I'd rather see too much than too little and miss something really important. There's also a quote recorder as well. If you want to tell us something nice about your experience of the course, you can use that. I mean, you can use it to say something horrible, but that's probably not the place to do it. This is an internal thing that we're using potentially to grab out some quotes that we might use in reports or bid writing, and we're probably not going to say they said the course was rubbish. Obviously, if you do feel like that, do speak to us and give us your feedback, and we can see what we can do to support. But so that is there too. So please add to that. We've designed it to be not onerous in the slightest, but it is vitally important. So register your projects and tell us about everything that you're doing that you're using these skills. Our entire existence depends on it, and indeed the existence of HSMA moving forward. Thank you, Sammy.
Brilliant, thanks, Dan. Yeah, and on the subject of feedback, there will be a feedback form next week at the end of the teaching phase, where there will be plenty of chance to tell us what we did well, what we could have done better, and so on and so forth. So please do fill that in when we share that with you next week, but there will be plenty of time to do so. On the subject as well of impact gathering, so I would like to welcome Gemma to our HSMA team. So Gemma has recently joined us at the University of Exeter and is going to be providing both admin support. So you will be potentially, if you get in touch with us about general queries about the programme, etc., as we go through the next phases, it may well be Gemma that you speak to. But Gemma will also be doing a lot of our impact gathering work. So following up with you to kind of flesh out those impact gathering stories, following up with you about nice quotes, anything else. So you will have plenty of chances to meet Gemma. And I'm just going to get out. There she is. She's popped her camera on. Gemma, if you can just give us a wave. Fantastic. Thank you very much. So we have, you will get to know Gemma as time goes on. But please do say hello to Gemma in the chat. And we look forward to what Gemma is going to bring to the team as we go through this next phase of HSMA. So thanks very much, Gemma. And Gemma will be hanging around for a little bit today. You may see her in one of your peer support groups. This will be the start of. We're really looking forward to having Gemma with us to make sure that we can gather all that wonderful impact that we know is happening. So fantastic, thank you. And the next and hopefully final thing on housekeeping I'd just like to flag up is the hackathon. So you may remember that we have a hackathon scheduled for, the date has gone completely out of my head. It was the day that the assessment was originally due to take place. So not next week, but the week after, the Tuesday of the week after. This is an optional hackathon, but the idea is that you can register your own projects, that you can register whatever you would like to work on, whatever you'd like to practice more, something that fits nicely into a little start of a day. However, we have only had one project registered at this point. So if we don't see a few more fairly soon, we will probably kind of not do that hackathon and we'll look to maybe run that instead in a few months' time. Dan, anything to add to that? When are we going to call it the cutoff of maybe not going ahead with that hackathon?
I think probably by the end of this week, if we haven't got any more than like one or two projects, I think it would be. Obviously, people. It's great to see that Dom's project idea there, and obviously, I'd encourage him to do that regardless. The idea of it was for you to sort of practice your skills, and sort of gently sort of ease you into the project phase. But obviously, if this is not of use or interest to people, then we won't run it. So we'll see what it's like at the end of the week. But if we haven't got more interest, then we will cancel that one.
Thank you, Dan. Yeah, so please do register, and it's a great chance to work potentially with some different people, to come up, have a chance to just practice your skills before you dive headlong into your project proper. So please do make use of that if it would be useful to you. Right, so with all that out of the way, I believe it is time to go back to Streamlit. So last week we built a couple of different Streamlit apps. We built a calculator that takes some user inputs and some outputs, outputs some values. Maybe you already have a simple calculator that exists in an Excel spreadsheet, and you want to now be able to turn that into a Streamlit app. Creating a Streamlit app, it has the fantastic benefits. It removes the risk of people having old versions of the spreadsheet knocking around. It avoids people breaking it by inputting values incorrectly. You have far more control over the user flow, the user inputs, than you can with something like Excel. It allows you to better constrain things, better respond to outputs, incorporate images, and it instantly makes it a multi-platform thing as well. You don't have people having to have the correct version of Excel on their computer. It's not a problem if they're on a phone. It instantly, whatever you've created is a multi-platform tool. The other thing that Streamlit apps can be really great for is doing something you couldn't do without Python. So obviously, whilst there are rumblings of Excel getting some sort of version of Python, being able to do things in Python and make that accessible to other people without them having to install Python and deal with environments and versioning, etc., is a huge bonus. So our app that we made was focused around word clouds, but you maybe want to do something else Python specific. Maybe you want to train a machine learning model and give them a way to interact with that model. So for example, you might remember ARM's project from the NLP hackathon, which allowed you to put in some text and the machine learning model would interact with that, the NLP would interact with that and give them an output, and they have no idea as a user that they're interacting with something Python based. So we also did a little bit around dashboards. That was allowing you to leverage Python's data visualization and mapping capabilities that are so powerful, give you easy interactivity. And this can allow us to replace lots of non-FOSS apps, lots of non-free and open source apps with solutions that have auditable code. Also allows you to start reusing and adapting code more easily, or sharing code across multiple apps. And even if you're not using Streamlit for dashboards, and a lot of you may already have a dashboarding solution in your organization, being able to arrange and display graphs, maps, and metrics are a huge part of many apps, and they are going to be a big part of the DES apps that we work on today. So as I say, this week we are going to mainly focus on building an app for running a discrete event simulation. And a lot of the projects that you do in HSMA do end up going down a simulation route. And the web apps are such a popular way to allow people to interact with these modules, but all of what we cover today will actually just translate really well to the other things that you have done on the course and may want to make an app to work with. It'll allow us to translate a little bit more complex existing code into a Streamlit app, which is something that you may find yourself doing quite often, building the code first and then going, right, how do I stick an app on the front of this? Sometimes you may build with the app in mind from the beginning. That's absolutely fine as well. But maybe you do already have some code, maybe in R, a bit of R code that you want to translate into Python. Maybe you want to turn that into a Streamlit app because at the moment it's languishing in a corner, and being able to make it something that other people can interact with will be hugely beneficial. The other things that the DES app really allows us to practice is allow a huge range of advanced Streamlit concepts, preventing the app running every time an input changes. I'm sure you started to find that quite annoying with your word clouds last week. It allows us to try out multi-page apps. So I know we started looking at tabs last week, but you still have that problem of things rerunning every time within all of those tabs. Splitting your app out into multiple pages can make it a lot easier to navigate and make it a lot more efficient. With that, we also want to start looking at things like session state. So generally when you move between those different pages, Streamlit has no idea what happened on the other page, but we can overcome that. And we can also overcome that problem of it losing the memory of what happened every time that you rerun the app, rerun some sort of calculation. There are ways to store that in its memory. Every time you load data as well, we deal with caching. Well, sorry, every time we load data, at the moment, data loads in. By caching that, which we'll go into in a lot more detail later, this prevents that data from reloading every time the app starts up, every time you click that run button, every time you change an input. That's hugely valuable for making your app run more efficiently and use less resources when you deploy it. Tying into that as well, we can choose certain parts of our app to rerun. So if you change a slider and it doesn't impact the graph over here, then we don't need to rerun that graph over there. We can start to define little bits of our app that work together. And finally, we won't go particularly into this today, but I can talk a little bit about memory management. As you start to deploy your app to the web, you will find yourself needing to control the amount of memory that Python and Streamlit are using so that you don't basically make the web server you are using topple over when lots of people start to use it together. But we will cover that as well, deploying apps to the web. By the end of today, you will have deployed an app to the Streamlit cloud service, and we will also talk about some other ways that you might look to deploy your app internally, etc. So before we kick off on all of that, I'm aware that it's been now 2 weeks since you last looked at Streamlit, so I think it might be worth us having a quick recap of some of the key bits of Streamlit. So I'm going to switch over to VS Code and make a little app. So time to share my screen, and I will close that one down. And I have downloaded today the repo from GitHub, and I've extracted it. So hopefully my repo looks more like what you have got today. I have just loaded it in, opened the folder, and what you have is this subfolder, which I haven't had before, of H67C web apps to main, and then everything within it in a level below. So you will see me moving around within the terminal more than before, hopefully mirrors better what you are experiencing yourself. So first thing I'm going to do is make myself a new app. I'm just going to go right click and new file over here in my Explorer window, and I'm going to just go my Streamlit recap.py. So remember that Streamlit apps, we're not working in notebooks, etc. We are working with .py files. I'm going to click enter, and now my app, my Python file is open. First thing we do with every Streamlit app is import Streamlit st. St is just the standard Streamlit import for my for all Streamlit code, just because otherwise you have to write Streamlit dot multiple times throughout your app, and it's very cumbersome. Now, first thing as well I need to do is actually change my environment. I'm not working in the right environment here, so you can see that Streamlit is not being found. I'm going to click down at the bottom right here. And remember, this will show up if you are in a Python file. If you're in a different kind of file, like a markdown, like the README here, it will not come up at the bottom right. At the bottom right, when I'm in a Python file, you get this little indicator of what Python environment you are running in. I'm running in a machine learning environment in this case. So I'm going to click down here where it says 3.11.4. Click in, and I get my list of potential environments. Now mine is probably a little bit longer than yours, but I know I want the HSMA web dev environment today. And that will have Streamlit and all of the other packages, such as SymPy for our discrete event simulation, installed within it. So that little error message about the import problem has disappeared now, and I am going to be able to start writing some Streamlit code. So the first thing that you may remember is the wonderful st.write command. Now, st.write is great because it's quite a clever command. Whatever we input, whether it's text, whether it's a data frame, whether it's something else, it will try and display it in a sensible sort of way. So I'm going to pass it in a string here, and I'm just going to go, hello, HSMAs. I'm going to save that, and then it is time to run my app. Now, remember, we do not run it like we've done before with run Python file or run an interactive window. That won't work for us today. Instead, we need to go into terminal and new terminal. And I'd recommend doing that even if you have a terminal open at the moment. Kill the terminal that you've got, go new terminal. Just it makes sure that everything is nice and clean. You can see we've got the brackets with HSMA web dev here telling us that we're in the web dev environment. Depending on your VS Code, that may not come up those brackets, but as long as you've selected the correct environment down here in the bottom right, it should have the correct environment in the terminal, even if it's not explicitly telling you that. Whether it says that or not, the best thing I can recommend to do is just to type in, well, let's just check where I am here. Now, I've made this in the wrong folder, so I'll show you what. This is something that I think tripped a few people up last week, and this is just navigating around in the terminal. So at the moment, you can see I'm in HSMA teaching H670 web apps 2 main. So this is where I am sitting. I have, because of the way things extract from our, when you download a repository, you end up with these subfolders. So I'm in my HSMA teaching folder. I have HC7C web apps 2 main. If I double click into this, I have another folder called H67C web apps 2 main, which is an absolute pain in the backside. But what this means is you can see that I have 2 folders with the same name. If I were to try and run now, Streamlit run, my Streamlit recap.py, this will run because you can see my Streamlit app is in this top level folder here, not inside this subfolder where all of my other sort of exercises, teaching examples, code examples, etc. are. And what I can do is bring in my Streamlit app. This may load up this may load up for you automatically within VS Code. Mine is set to run on a separate screen. So here you can see I now have a nice little web app showing hello HSMAs on the right here. If I change this, if I go hello world instead and save again, I get the option that I get told that my source file has changed and I need to rerun it, and now it's updated to hello world. So if I've just pressed Control-C here, and that has stopped my app running. You can see it's now sitting there going connecting. It's trying to connect to the little internal server that we've spun up to run our app code. It won't work. There's nothing there for it to connect to anymore. Why am I telling you this? Because I want to try and create another app inside the folder so I can show you moving around. So this time, making sure I've clicked on H670 web apps 2 main. And I'll even create another folder, actually. Let's go live demo. So I've now got inside my HSMA where I've extracted my repository, I've got a folder in here, and then I've got all these folders here, one of which is called now live demo. Nothing in there at the moment. So let's create a file called live demo, and let's call it demo1.py, remember, .py file. Now, if I make this a little bit bigger, you can see that at the moment, if I just do, again, import Streamlit as st.write, this is another demo, and save this before I do anything else. It's no good without saving. Now, if I were to try and do Streamlit run demo1.py, it will tell me that the file doesn't exist. It's an invalid file. And that's because I'm still sitting in this H670 web apps 2 main folder, and there's no file called demo1 in there. To change the directory that I'm in, I need to do cd and then start typing in the folder that I want to move to. Now, one of the useful things that you might want to try is pressing the tab key on your keyboard, and that will auto-complete with anywhere that you can move to. It will auto-complete with either a file name or a folder name. In this case, the only thing within this top level folder is the other folder that's also called the same thing. So I press enter, and now I am in here. Sorry, no, I was in here, I'm now in here. I've moved to this level. If I press CD again and start pressing tab, you can see that it starts cycling through all of the different folders that we have showing up on the side here. Live demo is one of them. If I press again, teaching example, and so on and so forth. So it's just CD, I want to move into my live demo folder, CD, change directory, and I move into my live demo folder. You can see that as we have moved through the folder structure, we've had our file path has got longer and longer. And the next thing we're going to do is try and run our Streamlit app again. So Streamlit, I'm just going to make this a little bit wider because it's starting to wrap. Streamlit, run. Again, if I press tab, this time you can see it's auto-completed to demo1.py because it knows there's a Python folder, a Python file in there. There's nothing else in this file, so pressing tab again doesn't do anything, and I can just click enter. Or I could just type in Streamlit run and I can type in the file name myself. Nothing wrong with that, demo1.py, but pressing tab is really handy. So I'm going to press tab now, and you can see we've got a new app up here. This is another demo. So I'm going to show you another quickly recap a few of the key Streamlit commands before we go on to our DES app. I'm going to kick off with st.title. So st.title gives us a nice big title in our app. So this is my title. I'm going to save. You can see source file changed. I'm going to rerun. And now we've got a larger bit of text at the top of our screen. We've also got different sizes of text. So we've got st header. This is a header. We've got st subheader. This is a subheader. If I save now and rerun, you can see that we've got these changing sizes of text as we go through our app. We can also do anything that we can do in a normal Python file. So for example, I am going to import pandas, SPD, pandas being our standard way of reading and writing tabular data. And I'm going to load in my penguins file from last week. So I need, in this case, because I'm in a subfolder, I'm going to create a variable called, I'm just going to call it df, data frame. And I'm going to do pd.read CSV. And I'm going to do penguins df.csv. I'm then going to do st.dataframe and df. I'm going to save that. Now what we're going to see is this isn't going to work. It's telling me that there is no such file or directory called penguins data frame because, again, you can see that we're in this live demo folder. Penguins data frame is in the subfolder, the folder one level up. So we're in here and we need to go back up one level to where this penguins data frame is stored. How do we do that within code? I do 2 dots and /. And that code basically just tells it to go up one level and look at what's in there instead. Save that, run that, and you can see now that I have managed to successfully load in my penguins data frame. If the penguins data frame was actually within the live demo folder, I wouldn't have to do that. I could just have it as penguins.df.csv, rerun. And you can see this time it's still working because my penguins data frame is now in the live demo folder. This is probably the biggest pain with a lot of Streamlit is just getting, if you haven't worked in the terminal much, then just getting comfortable with where you're loading files from, where you're loading your Streamlit app from. This is the thing that will probably trip you up most throughout the day and probably trip you up a lot last week. Hopefully, the more you move around in the app, within the terminal, you will start to get comfortable with understanding where you currently are and where you need to be. So just remember CD to change directory. And if you ever need to go up a level, whether that's to look around for a different data file or whether it's actually to just move, if you've realized you've gone too far, I don't want to be in live demo anymore, CD, 2 dots, and now I'm back in this higher level. I've just within this subfolder. So I'm going to quickly check just to see if there are any questions about this before I move on, and then we can start doing some more fun things with our DES app and with this current app that we've got. Dan, anything I need to address?
I don't think there were a few sort of questions that came up, but I don't think anything. Oh, it's just post issue. A stream app facilitating data requests from GPU providers. Did you any thoughts on that? Sorry, I've literally just seen that. So.
Yeah, so using the Streamlit app facilitating to question GPU providers for ETL process. Yeah, I think it is something you could do. The difficulty and a lot of things that you'll probably find you want to talk to us about as you work through any Streamlit-based projects is just that data connection. It depends. I think Dan has run into this a little bit with creating the PIMS app that we talked about at the start today. Connecting to your data sources, connecting to where you want to write data as well, anywhere you want to persist data, can be a bit of a pain. It's absolutely doable. It depends a little bit on the will of your organization and what kind of data you're trying to store. I think it works. Sorry, would you facilitating data requests from GPU providers and then performing ETL processes on Python to load the data into an SQL data warehouse? I think it very much depends on what you're trying to do and what you are allowed to connect to within your organization. So when you're hosting something on Streamlit Community Cloud, for example, you may find that there are more restrictions on what you are able to link to, on what your organization are happy for you to link up to. If you are loading something on an internal server within your organization, there may be easier ways to connect to internal data, to write to internal databases, to read from internal databases, but then you have a bit more overhead and you need a bit more agreement from your data team to get things running. So yes, with caveats, absolutely something we can discuss further and maybe look at as a potential HSMA project. So, right, we have, oh, Dan, I think you may have just come off mute.
Sam, Sammy, I was just going to very quickly say, Charlotte's just posted. I've not heard of this. Have you heard about this thing? It's getting a warning that to install the Watchdog module for better performance. I've never seen that. Is that something you've encountered?
No, it's not something I've come across either. I wonder, is this on Linux potentially? I'm not, but I think you're probably fine for now to leave it, and we'll have a bit more of a look into that if it's something. Oh, okay, so it's also it could be a Mac thing that might. Yeah. You and I haven't come across it yet, so I'll have a look into this and see if I can give you any advice. But for now, I think for the complexity of app we'll be working with today, you shouldn't need too much performance basically, so should be fine. Fantastic. So, right, let's have a look at a little bit more of the Streamlit commands that we ran through last week. So I'm going to make sure that I've got my app running again. I'm going to go cd, I need to go into live demo, don't I? And I'm going to go Streamlit run, and I call this demo 1.5. You see mine's loading more and more new tabs over here for me, so you might want to just make sure you're closing down tabs where you're no longer connected. What you'll also see is here we've got localhost 8501 as the URL. Don't worry too much about what those exact numbers are. This may look different on yours, but just be aware that as you start and stop apps different times, the numbers after that may change. So what else can we do within our Streamlit app? Well, we can also display plots. We can display matplotlib plots. We can display interactive plots with Plotly. I am going to do import plotly.express as px. Now, Plotly Express is this really nice graphing module that allows us to create simple interactive graphs without too much code. Now, what I'm going to do is streamlit.plotly chart, because I know I'm creating a Plotly chart and I want Streamlit to display it for me. I'm going to tell it that I want to pass in my data frame as my data. No, wait, I need to tell it that I actually want a Plotly chart. px.scatter, I'm going to do a scatter plot, so dots on a plot with an x-axis and a y-axis. I want to pass in my penguins data. This is our penguins data. Remember, we've got columns for bill length, bill depth, flipper length. We've got species as a category, island as a category, sex as a category, so on and so forth. On the x-axis, I'm going to choose one of my columns to display. So I'm going to do, let's do bill length in millimeters. And on my y-axis, I'm going to do bill depth in millimeters. So that's the code at this point. I'm going to save this. Remember, I'm going to rerun. And now further down the screen, we get this nice little interactive scatter plot. If we hover over, we automatically are able to see the value for that exact instance. And we can just do anything we would normally do with this scatter plot. We can start adding in things like color. So let's color the points by the species of penguin, save that, rerun. And you can see now that our scatter plot has updated. And again, this is a really nice way, you know, that's something that Streamlit does so well, is allow you to do this very iterative, interactive development. You may find that you just like developing in Streamlit in general, because it's a really good way to try things out and quickly get this sort of responsive feedback and be able to see what, you know, what you're doing with the data that you have available. Now, I think I'd prefer to be able to see these side by side. So I'm going to put them into some columns. Now, Streamlit has loads of really nice layout elements that you can access. So we have tabs, we have columns, we have expanders. So let's start with our columns. I am going to create, let's say I want 2 columns to start with. What I need to do is give these columns some names. So I'm going to call them just column 1, column 2, and assign the output of ST columns to those 2 variables. And what that just means is then I have a column 1 that I can access and put stuff in, and a column 2 that I can access and put stuff in. I'm going to do with column 1. So inside column 1, please put my data frame. Inside column 2, with col 2, please put my plotly chart. I can highlight this whole lot all at once, press tab, it all indents, and now it will all sit within column 2. Everything indented one level within my column will be displayed within the column. If I rerun now, you can see that these are now displaying side by side. You can see it a little bit better here. Now, if I were to instead decide that actually there's not really enough space to display these side by side, maybe I want it so that users can click through some different tabs. Very similar. This time we have Streamlit tabs. So I'm going to rename these to tab 1 and tab 2, just so I can keep track of what's going on. Otherwise, it gets a little bit confusing. So with tab 1, with tab 2, the only difference is instead of passing in the number of tabs I want, I pass a list with the names of tabs that I want. So I'm going to call this data tab and chart. I'm going to save that and rerun. And I'm going to break my app, it would appear. What have I done here? There we go. Don't know why that didn't rerun perfectly the first time. You can always refresh your app using the standard sort of reload commands. So this time we have our data tab and our chart tab, and the user can move between the 2 and see whichever one they want to see without doing lots of scrolling. Now, anything else that I want to tell you before we go on to the remaining stuff? Streamlit Expander. Let's quickly remind ourselves of Streamlit Expander. So this time we do with st.expander, and we pass in click here to read more about penguins and a colon. So you will see a lot of this with notation within Streamlit. You might remember it from way back when we did some loading in of files, but the good thing about Streamlit is just basically going within this layout object, put everything. So within my tab, within my column, within my expander. The expander is just going to be something that gives us a little header that says, click here to read more about penguins. And whatever we put within it won't show up by default. It will only show up when the user clicks. So let me just put here, Streamlit.write. There's nothing here right now. I'm going to save it, rerun. And why is this not behaving? Oh, so for some reason, you will find this occasionally. Theoretically, everything that you put in order should appear in the order it appears. Maybe it's because I put this after I had created my tabs. Let's try that again. And there you go. So I needed to, and even though I hadn't initialized my tabs at that point, I hadn't put stuff in my tabs, I'd created my tabs. So I needed to put my expander before my tabs were created if I wanted them to appear above my tabs. And that's a good demonstration, actually, of the fact that everything in a Streamlit app runs top to bottom. It's very much like a normal Python script in that sense. So when you're setting up your layout, you need to think about the order your code is being written in. That will define the order that things appear in. So here, click here to read more about penguins. And there's nothing here right now. That's what we told it to tell us. So now I can close that again and it will hide it away from the user. I think those are the main layout elements. You can bring in a data frame, you can bring in a plotly plot, and all of this, remember, is always recapped and available in the Streamlit book. So if you can't remember any commands, if you can't remember how to do something, go and have a look at the Streamlit book, and the command you want should be in there. But let's head back to our slides, or I'll just quickly check anything else that we want to talk about. Yep. So I will quickly close down my app before I move on to doing anything else. And as Dan has pointed out in the chat, if you close this tab and then try and shut down your app, you will probably find that Streamlit doesn't want to close the tab, stop running your Streamlit app. You will just find that this hangs. Nothing seems to happen when you try and stop the app. So leave your tab open, come over to VS Code, type in Control and C, and it will stop the app from running. If you've closed your tab and you don't want to reopen it, you can just kill the terminal that you're using and start up a new one instead. That is also absolutely fine, but it's just a little bit neater to stop your app with Control and C, and then you can do whatever you want, load up a different app, do whatever you fancy. So I'm going to close this window for now as well and just head back to VS Code. Let's have another look at anything else that's come through while I've been chatting there. Hopefully that has been a nice little refresh of how Streamlit works. Streamlit window on the right, yep, so depending on your VS Code settings, yours may just open up on the right within VS Code by default. I can't remember exactly where that setting is defined. Mine automatically seems to want to open up in a separate browser window, but you can just snap them to either side of your window. And yeah, and is there any reason that you don't declare the expander as a variable and call it in the with line, like with the tabs? Yep, so as Dan says, that we only need it once. We won't be going back and adding additional things to that expander. We'll generally create it at the point, that point in time. I think you might be able to do that. Let me just have a look. Let's see if that actually works. So my expander is this expander. So let's see if we do with my expander. And run this app again. Load this up over here. Oops, break everything in the process. There we go. So this seems to have run absolutely, yeah, so this still works. So you can save the expander as a variable. You probably generally won't want to do that, but actually what it might allow us to do is go down the bottom here. So I won't demonstrate it for now, but there is a nice little way that you can actually continue to reference things like your columns and like your tabs and add additional things into them after you've first used this with notation. Take a look at the Streamlit book if that's something you want to do. It's generally something you'll only want to do with more complex apps where you might want to do a calculation further down in your code and then make sure that actually that goes into a particular tab. You probably generally won't get into that, but it's worth knowing that there are some additional ways that you can refer to columns and tabs that you've created that allow you to do some more complicated stuff with them. Take a look at the book if that's something of interest to you, but I won't confuse things too much by going into detail with it here. So, right, that's a little bit of a recap done. Now we can hopefully remember the key parts of building that Streamlit app. Let's think about how we can start joining this up with a discrete event simulation model. And before we do that, let's have a think about what our output might actually look like. So discrete event simulation app, well, you probably remember some of the inputs from last week, things like sliders, things like numeric inputs. A lot of the time, sliders work really nicely for a discrete event simulation app because you generally want to give people some options between a range. You don't generally want to allow them to put 1,000 nurses into a model because it's not very useful and you probably break the model in some way, or you don't want to let them run 20,000 runs of the model because it will take forever and probably make your server fall over. So sliders are a really nice visual way of allowing people to put in an input to a discrete event simulation model and change things like how many nurses are available, how many rooms are available, how long on average does a consultation take, how long does a consultation vary by, how many runs of the model do you want to do, how long should the model run for, should it run for a week, a month, a year, that you want to allow your user to change those things, how many slots are available for daily appointments, something like that. We can also provide users with a range of outputs within a discrete event simulation model. And again, Streamlit is really nice for allowing you to create nice visual indicators of, things like here are our utilization metrics in an ideal range. Well, Streamlit can calculate that and then spit out to the user, both the utilization metrics, the number of beds in use, the number of nurses in use. Those are in an ideal range. Fantastic, user knows that those parameters are great. Or in this case, 0 of our utilization metrics were in an ideal range. We can give them a little bit more detail about what that means using our st.write command. We can give them a nice quick visual indicator of a metric, of a KPI, of something like that with an st metric. That's what this at the top is. And we can also use our plotly plot. So at the bottom, we've got our st plotly plot showing our utilization graph. And this is just some data that we have pulled out of the runs of our model. Now, the code I'm going to give you today is going to give you a load of graphs to get you started with. But as you continue to work with your simulation models in your projects, you will find that you want to add more and more or get more and more out of your model. You can track things like how much of the time were each of your resources in use, how long were the queues at different points in time, all those sorts of things. How long on average were people waiting? How long was each individual waiting? What percentage of people exceeded a wait target? And we can start to give this all out as information to the user and think about how we can display it in such a way that the user doesn't have to do too much work themselves. So we can give them things like bars showing, this is the ideal range, a green indicator that this is good. We can give them, we can interweave Python variables with text to start showing things like, if you changed your target wait time, for example, you could set that as a parameter in your model and let them put in, pull this into your output text saying you didn't want people to wait more than 240 minutes and pull that into your graph, etc. So you can, through this, you can give users the power to change things, but you can also guide their journey through the outputs. You can give them a helping hand to understand what the model is saying. We can start to give people more and more ways to avoid overwhelm or giving power users more control over the output. So remember this st expander we just looked at? Well, over here in the advanced parameters, this is an st expander. So they can start to look at those additional advanced parameters without having to look, with most people don't really care about the random seed that you're starting from. You can just give your standard users the easily accessible parameters for them to play around with. And also you can start to use things like tabs to give users the level of output they're comfortable with. Again, you might want most people to just see the simple graphs, and then you might want to have some tabs so people can start to look at the advanced graphs. So you can start to see how we can build up these relatively simple layout components that we practiced last week with our dashboards and pull them into a really powerful but user-friendly app at the other end. And the possibilities really are endless as well. There's a couple of additional things that we haven't really talked about yet, like editable data frames, and what this will allow you to do if this doesn't crash. So here we've got things like our ST I think this is ST warning. So we've got a little warning message for the user when they load up. We've got multiple pages here over on the side that we'll talk about later today. We've got a flowchart. This is a code-based flowchart. We can talk about additional details of the model within our ST expander. And here we can start to do things like editable data frames. We've got a series of clinicians who are available to see people on different days of the week. Users can start to go in and change on the fly. Well, now there's Clinic 4 has 10 slots available on a Wednesday. Clinic 8 has opened up and it's got 9 slots available on a Saturday, so on and so forth. And that will go straight into the model and work. So what we're going to need to do is replace some of the inputs to our DES model with sliders and drop downs and more. So that's all we need to change, is how does the model get the input? And we also want to do something with the output we get from our model. We want to remind ourselves first what we get out of our Streamlit model, so we can provide some tables or some graphs that our user can view and maybe even download as well. So let's go back a few months and give ourselves a quick recap of what DES is. Hopefully you sort of remember that, but I'll just give a little bit more of a recap and how a DES model, discrete event simulation model, is structured in Python. So discrete event simulation is something that can be applied to any sort generally of queuing problem. Healthcare in particular does involve a lot of queuing problems, diagnosis pathways, emergency departments, mental health treatment. A lot of problems that you don't immediately think, well, that's a queue, can be framed as a queuing problem. You have people flowing through a system in some way, and generally at some point they have to wait, or kind of there's some sort of delay somewhere in that pathway, even if they don't see that delay themselves. You know, people coming in for an appointment, they get booked in, they go and have that appointment. They don't necessarily see that as a queue that they're in. They've just been booked in, gone and had an appointment, but it's still kind of a pathway problem, a queuing problem. So you can really apply discrete event simulation to a lot of stuff in healthcare, more so perhaps than some of your policing and public health type problems, but it is still a very good one to be aware of. So what we have in our discrete event simulations are entities. A lot of the time we'll talk about these as being patients. They don't have to be patients, but a lot of the time they are in our models. And these people flow through a pathway. The pathway can be as complex or as simple as we want it to be. Generally, in some way, these entities need to arrive in the system. So in our very simple model, they're going to arrive at a surgery, at a location. They're going to sign in with a receptionist. They're going to be triaged. Then they might go through some sort of branching pathway. Again, this isn't mandatory, but a lot of time maybe these people are triaged and some of them are less seriously ill and go and just see a nurse. Some of them go and see a doctor. Some of them maybe need additional tests. Some of them maybe don't and just go straight to being discharged. Some of them might go back around this loop a few times. We can add in all of that variability and we can run hundreds of simulations of different days, different combinations of patients who all go down to slightly different combinations of these pathways and stress test our system. And along the way, we will get them to use resources because we don't have an unlimited number of nurses. We don't have an unlimited number of beds. So somewhere along the way, they need to be using these resources for a defined period of time. That defined period of time doesn't have to be the same for every patient. It might depend on how ill they are. It might just be that there's some general random variation in how long different things take to do. But during that time, they will use this resource, they will hog this resource until they are done using it, and then they will pass it back. So the resources get in use for a certain amount of time, and we can track things like how long did people wait, how much of the time was the doctor in use. We can give doctors breaks. We can make certain beds unavailable whilst they are being changed. We have, because of the flexibility of discrete event simulation code in Python, if you think you need to model something in your system, you can model that in your system. Now, SymPy is the Python package that we use to allow us to create these discrete event simulation models. What it does is provide these building blocks like resources for us to put together into highly customized discrete event simulations. Now, there are multiple ways to structure a SymPy model, and it's generally a good idea to use what we call object-oriented programming. You've come back across this in your agent-based modeling, and you've got practice with it back in discrete event simulation world. You can do SymPy without object-oriented, but it gets very complicated very quickly. The good news is all of the model code that we provide on HSMA uses the same for object classes. We're going to have our G class. This is where we store any global level parameters for our model. So what do we mean by that? We mean things like how long is the simulation going to run for? How many nurses do you have? How many doctors do you have? How long on average does something take to run? We then also have our entities, our patients. Now, patients carry with them information that we can record to or read from. So we could have patient, we could have multiple kinds of patient. Maybe we have some patients that go down a trauma pathway, some patients that go down a non-trauma pathway. Maybe we have people coming to a clinic and some of them, or a diagnosis clinic, some of them have ADHD, some of them have autism. We can have as many different types of entities as it makes sense to have. But in our case, we're just going to have one, and it will generally be some sort of patient. Now, you can almost imagine this as a reproducible template for a person. And this person is carrying around a little clipboard with them, and it says, this is my name, or this is my ID number. And as I go through the system, I'm going to record how long I waited here, how long I spent with this doctor. So at the end of the model, we can look at our little, we generate a new patient from this template. We put them into the system. At the other end, we look at how long, we grab their clipboard from them, and we grab the clipboard from every patient who's gone through the system, and we can start to calculate on average how long did people wait. But because all of that information is stored, attached to the patient, it's really easy to track things like individual patients through the system. It's really easy to understand you don't lose track of the people that waited a really long time. You can look at different types of patients and separate those out, average out how long did it take for a trauma patient versus a non-trauma patient, and so on and so forth. So you get a lot of value from having these little reproducible patient blobs, effectively. Now, the model is our third class. This is the really big one that represents the whole system we are modeling. In this case, this is going to be our clinic, and it can be whatever you want, again, but it's just defining the journey that people will take through our system. It has our generators, has our patient journeys, and it's where our SymPy environment, which is our sort of little universe where time will tick away, that's where that will live as well. And it will also have a method for running the model once. So from our model, we can go, right, I want 1 day in the life of this clinic. But 1 day in the life of this clinic is not very representative. So what we want is a final class that allows us to run batches of runs, run 100 days in the life of the clinic, and start looking at those averages over time. Start looking at the really bad days, the really bad runs, the really good days, and also tell us on average, how is our system going to do? How much of the time is our system going to cope? How much is it not? That sort of thing. As I say, within this world, a single run of a model we will refer to as a run. A batch of multiple runs with the same parameters is known as a trial. Now, I keep saying about the trial being great because it's different days in the life. Well, how is it different days in the life? We build randomness into our simulation models. Computers aren't very good at being random, so we generally give them a little nudge to be random in different reproducible ways. This is really useful because it means we can run 100 runs with a very slightly different, patient A turns up 5 minutes later than they would have in the first run of the model. They spend 3 minutes longer with the doctor than they did in a different run of the model. And by that point, 5 different people have already turned up, but in the first day of the model, no one turned up. It's been a really quiet day. But on those 2 days of the model, we keep other things consistent. We keep the number of nurses consistent. We keep the number of doctors consistent. We keep other aspects of our system the same, so that as we start to change things like resources, we can be confident that it is the change that we are making that is making the valuable change to our system, that is what is changing the outputs we are seeing, the performance of the system. So the good news is If you're going, this feels like a really long time ago, and I don't really remember that much about discrete simulation, and actually you've just confused me more, you actually only need to interact with one of these classes today. When making a Streamlit app of your DES model, most of the changes will be in the G class. You can basically leave all of your other classes untouched. So the only things that you will really need to be changing are your G class, your parameters. So remember that's things like the list, the number of doctors, how long the model will run for. All we need to do is create a way for the user to interact with that. And at the other end, we need a way for Streamlit to display any of the outputs from the model. So the data frames telling us on average, how long did someone wait, all that sort of thing. So I'm going to say before we kick off with this, let's take a 10-minute break, have a quick coffee, and then we will come back. I will demonstrate how I would change the code, and then we will go away and do our exercise. So let's, not quite 10 minutes, but let's have us back at 20 to 11. We will regroup and we will go through the rest of this section, and then you will be set off to have a nice long time to work on creating your first discrete event simulation front end. So I will pause the recording and I will see you in a moment. I'll try and pause the recording. I've lost my, there we go. I'm also going to resume. There we go. So let's share my screen and we will have a look at turning our model, our discrete event simulation code into an actual working web app. So what I've got in here is in this teaching example folder, I've got some teaching starter code. So if you do want to follow along, that is where you will find this code. And it is just one of the very simple models from back along in module 2. So what we have here is our G class. We've got patient inter-arrival time, the average inter-arrival time between patients. So on average, it's 5 minutes between patients turning up at our clinic in this case, but it does vary. Again, we have an average consultation time, but this does vary. So on average, 25 minutes with a nurse. In this case, we only have nurses in this system. And but it may vary. In this case, we've used an exponential distribution, but it might be that you want something like a normal distribution. It might be that you want an exponential distribution, a log normal distribution, all sorts of distributions you can use. Do head back to the DES book if you want to talk a little bit more about distributions. But the key thing to remember is that basically there is some level of variation here. We're saying that on average, it takes 25 minutes for a consultation, but it can take more. Number of nurses we've specified here, 10 nurses, sim duration of 720 minutes. Remember, SimPy doesn't really have a concept of minutes or seconds or hours. It just has time units. So you can control what that means. And in our case, it's useful to run in minutes. So we've defined it as 720 minutes. You just need to be sort of consistent with how you're thinking about time throughout your model. So here we've got 25 minutes for an average consultation time. We then have our patients. So we have this patient class, they get an ID, they get a queue time for the nurse, which at the beginning is 0 because they haven't queued for anyone yet. And we also record what time they arrived in the clinic. We then have a model for our clinic. Again, like I say, we don't really need to worry too much outside of this G class. So I won't go into detail here, but we have this model of our clinic that will allow people to run through the model. They will actually run through a pathway here. They see the nurse and then they leave. All we're recording really is how long they queued for and what time they turned up. Then we have our trial class. This is where we actually allow ourselves to run multiple trials. So run these 5, I think in our case, 5 runs we've specified. So we will use the trial class to run 5 sample days of the clinic. The other thing we do here at the end of this particular one is we output a load of different results. So we output that the median wait to see a nurse across all runs, so across our trial of 5 different days, what was the average time that people queued for the nurse? and a couple of other just different things that we're kind of pulling out of our simulation runs. We had a target of 60 minutes. So how many runs did the average wait exceed that target? How much variation is this? We get a little bit of a box plot showing some data, and we get some plots showing things about how long did people wait against the 60-minute target, etc. You don't need to worry about the code for all of these plots right now. The main thing is, let's see what happens when we run it. I'm just going to have to move this because this is the zoom controls are hiding what I need to be able to do, unfortunately. And you will do the same in your code when you go on to the teaching phase of this, sorry, the actual exercise phase. You will have code very much like this for a slightly more complex model. It will have some sample outputs, some data frames, some text, some plots, and you might want to think about how you can display those to your end user. So what I'm going to do before I kick off and actually try and turn this into a Streamlit app, it's just a standard bit of Des code right now. So I'm going to click Run or Debug, and I'm going to run it in an interactive window. So remember, not a Streamlit app at the moment, no Streamlit elements in here, it's just running the SymPy code. And it's spitting out loads of outputs in our sidebar here, and yours will look similar, the code you work with for this exercise. So here, well, we had 10 nurses, so actually we didn't really have much wait because we didn't have that many people turning up. Let me change this down to, let's say, this one nurse, so we get some queues building up. And I'm going to rerun this. If everything would stop hiding under my zoom controls, that would be fantastic. Run current file in an interactive window. And you can see now that the graphs haven't quite displayed, but what we're getting is we get some text spitting out about what the plot shows, we get some data frames spitting out here. Again, you can see this is just not very nice. You know, if a user was to actually try and use this, you know, themselves, trying to change these values, it's not too hard for them to change the values, but to actually interpret this output, it's really not very user-friendly. So we know that we have a load of outputs, we have plotly plots, etc. Let's start turning this into a Streamlit app. For now, I'm just going to comment out this lot just because it's in the way. We've got way too much to deal with down here in terms of outputs. I'm just going to highlight the whole lot, press Control, /, and the whole thing comments out for now, so that won't run. The main thing we do need to care about is that we get the output of this trial, run trial. That will be the same in every HSMA model, DES model that you run. We run trial.run trial to actually get outputs of our model. And from that, in this case, we get a results data frame and a detailed results data frame. I'll show you the difference between those two in this case in a moment. So turning it into a Streamlit app, how are we going to do this? Well, first thing I want to do is actually import Streamlit as well. So I'm going to do import Streamlit. And very much like before, I'm going to do st.title. I'm going to call it Linux simulation. I forgot to import this. It's T. There we go. Well, let's see what happens for now if I just try and run this as a Streamlit app. So terminal, new terminal. Now you see I'm in a brand new terminal and I'm in here, basically, H6, 7C Web Apps 2. So I need to move H6, 7C Web Apps 2. And now I'm in here. And now I can go CD teaching example. That's the code I'm working on right now. And I'm using teaching starter code. So I'm going to do Streamlit run teaching starter code.py. Now you'll notice as well that every file name that I've created when I've been doing a Streamlit app has had underscores. It's not had spaces. Spaces are a pain when you are trying to run things from within the terminal. It's better to have underscores or just no spaces whatsoever. So you can get around this, but just for now, I'd recommend renaming anything that's got spaces in it to just use underscores instead. And I'm going to do enter. And now we've got a Streamlit app loading up. And at the moment, this just says clinic simulation. So it's run a load of code. It's actually run the model for us, but it's not output anything. So even though we've got all this code running behind the scenes, all we're seeing is our st.title simulation. Now, the next thing I want to be able to do is allow the user to input some values. I want them to, let's start off with, for example, the number of nurses. Now, I'm going to do num nurses slider. Call that whatever I want. I can change that as I see fit. But what we want is an st.slider. This is one of our input classes or input functions. I need to provide a label, choose the number of nurses, and for now, I'm going to pass in a minimum value. So I don't want them to be able to have fewer than one nurse. That will really confuse the model. And I don't really want to allow people to have more than 10 nurses because, let's say, our system is very unlikely to have more than that. So I'm going to save that. And I'm going to rerun. And now I've got a slider for the number of nurses. Now what you'll see is actually this changes, but doesn't do anything at the moment. It just allows us to have this slider changing. So I now need to link this up with the number of nurses in my G class. So I'm going to do num nurses slider. This is the variable that we've created here that captures the number of nurses that the user has chosen. And I'm going to link it up to my G class. Now, again, if I rerun this for now, nothing will happen because, well, the model's running, but we're not getting any outputs. So I'm going to head down to my list of outputs and see what I've got. So the first thing here is a print statement. The mean wait to see a nurse across all runs was this many minutes. What it's doing is it's looking at our results data frame. It's looking at the mean queue time for the nurse. It's spitting it out as a median, and it's putting this into a nice string. All I need to do with the print statement is change it to st.right. So save that, rerun, and now you can see with 5 nurses, median wait to see a nurse across all runs 24.8 minutes, and we cross our fingers. If we change it to 2 nurses, 198.1 minutes. Change it up to 9 nurses, 0.2 minutes. So you can instantly see that this slider is doing what we think it needs to do, or what we want it to do. It's changing the number of nurses. It is rerunning the model, because remember, Streamlit, every time we change this, runs the entire code top to bottom. It goes through and it goes, right, okay, you're defining these classes for me. You are passing me in a number of nurses, and then I'm going to go all the way through this. I'm going to run this trial using the trial.run trial. That's the bit where it actually does something. That's the bit that runs some code, and then it outputs these details. So we could go through and change all of our print statements from our original code into st.right, rerun this again. You can see now shortest average wait of 0 minutes. That's not a very good one, so let's get rid of that. Let's just print the actual data frame. Let's do st data frame. You can see what we're getting out of our trial is a mean results data frame and a detailed results data frame. So just when you go into your exercise code, look at what is being output from that trial and trial. Look at what's on the left-hand side over here and see what you can display. So let's do st data frame, mean results data frame, and rerun it. And you can see that again, as we change the number of nurses that we have in our simulation, the mean queue time for the nurse is changing. Now, I think the issue we have here is there's a little bit of an error with the run numbering in my sample code. So that's why we were getting that 0. Run number 0 is never being overwritten. That shouldn't be happening in the code that I've provided you for the actual exercise. So that's just a little bit of a bug we've got here. But what you're seeing is in all the other runs, as we change the number of nurses, the mean queue time is changing. So that's all we need to do now, actually, is we need to just go through and create additional sliders. So I'm going to do mean consult time slider. We don't have to call it slider, but I find that's just a very easy way to keep track of what you're actually changing. So again, I've just copied and pasted that because all I want to do is exactly the same, but I want to choose the average consultation length. This time I don't want the consultations, let's say, never going to really be on average less than 5 minutes. That's very unlikely, but they're probably never going to be on average longer than an hour. Let's save that, rerun. And now we've got 2 sliders. And as I change that, you can see that as the average consultation length increases, the average queue time is generally increasing. We're getting a little bit of random variation again, just because we have this randomness in people arriving, the arrival patterns. But in this case, that's because we haven't really controlled for the randomness very well in this code. There's a lot more about that in the DES book when you get to your own projects. But changing the number of nurses, you can see it's having a really significant impact as well. If I change the average consult length, well, we're getting down to almost no queues as the number of nurses changes as well. We can do different kinds of inputs. Let's say for the number of runs, let's do num runs numeric input, st number input, set the number of runs. I'm not even going to set a default this time. I'm going to tie that up. Oh, and of course the consult time, I hadn't tied it up there. That's no wonder that wasn't quite doing what I was expecting. There we go. Let's actually make sure we tie up the mean consult time. And while we're at it, we'll tie up the number of runs with the numeric input. So we're just slowly replacing these defaults in our G class with what we are passing in from our user's value, from the user's input. Rerun that. Now, in this case, it's expecting an integer. So what can I do here? Let's set the default value to 5 runs. Rerun. There we go. So now it's understanding that we've passed in an input because we've passed a default value to our numeric input, this one here, that is a integer. So it goes, oh, well, you probably want integers throughout. Now, I don't know if this is the most user-friendly way of doing it because, you know, they can now put as many runs as they want. They can just keep pressing this plus button. And you can see it will, well, it'll take a little while now because we're asking it to do quite a lot of runs. And as each time they've pressed the plus button, it's tried to do a new number of runs. So it's actually got a load of code backed up in its system at the moment, running it for 29 runs, 30 runs, 31 runs, and all the ones in between. But that's something we will talk about dealing with a little bit later in the next section. So I'm going to stop that running for now, just because otherwise we'll be here all day. So I'm going to set that back to 10 runs, press enter, just refresh it actually. Oh, no, that's run okay. So yeah, 10 runs, and you can see we're getting this output from our code. So I could go through and I could change the sim duration to be an input as well. I could change the patient inter-arrival time to be an input. You can do as many or as few of the parameters in the G class as user inputs as you want. You can leave them as default values. Also worth noting that within, you know, if I refresh this page now, it looks like the default number of nurses is being set to 1 and the average consult length is being set to 5. Maybe we don't want that. Well, we'll pass in instead as an additional argument to our slider. Value equals, I'm going to set it to 5 nurses by default. And I'm going to set the average consult length to 25 minutes. So we can just start tying up what the user's default input will be. So if you refresh now, again, you can see it's sitting at 5 and 25. If I were to change this to 35, average consult length, rerun, you can see that the average is now, the default is 35 minutes. So you can control what the default parameters will be that way. Final thing to do here, I'm going to go and take a look at some of these other outputs. So you can see we've got loads of print statements here throughout all of my different code. I've got these print statements. I've got a figure here. Let's see what we've got. So I've got a figure that looks like a px.box, some sort of plotly box plot of the mean queue times for a nurse. So I'm going to uncomment that. I'm going to go control and /. That just means I get this code back. And actually, if I were to run this now, even though it was going to run and create, it won't do much. Now, when I'm creating a plotly plot to display in an interactive window like this, I need to do fig1.show. So I've created a plotly plot. I've called it figure1 or fig1. And I need to tell the interactive window that I actually want to see this plot. Thank you very much. This time instead, I don't need to do that. I need to do streamlit.plotlychart, and I want to display fig1. I'm going to save that, going to rerun. And now we've got our box plot. This code has created the box plot. This code has displayed the box plot. And it's got a nice little title above it. That's built in by a plotly. We could also add our own titles, our subheaders, etc. So I could change this print statement to its st subheader, for example. Save that, rerun. And now we've got this subheader here, variation across runs in mean queue time for nurse. And we can start looking at the mean queuing time for the nurse run. Quickly going to check the des here, the chat here, sorry. Right, and the other thing that I want to show you before we carry on, so I'm just going to go through and check I haven't forgotten anything. So sidebar. Now, there's a lot of scrolling going on here, isn't there? No one likes scrolling. So what I'm going to do is going to head back up to my inputs, and I'm going to put them in a sidebar. So that will just mean that it will appear over here, all of our inputs, and our outputs will take up the rest of the screen. Now, we go back to our with notation. Remember, like with our columns, with our expanders. So with st.sidebar, and we don't even have to tell it, the sidebar doesn't have a title, etc. We just do with st.sidebar, and I can select all of my inputs here and indent them one level. All of those inputs will now live within the sidebar. If I save this and rerun, you can see all of my inputs have moved over to this nice little bar on the side. I can scroll this bit independently, all of my results independently. I can change the number of nurses, etc. And all of this is updating nice and live on the side of my screen responsively. If I were to make this a little bit bigger, you could probably see that a little bit better, what is changing as we change. So sidebars are a really nice way for certain kinds of apps for you to store your inputs, to store some additional detail, some information, etc. So in the slides, you will find some common examples of different kinds of inputs, just a bit of a reminder of things like text inputs, text areas. To be honest, for this exercise, you probably only need sliders. You can use number input like this one here if you so wish, but sliders, as I say, are a really nice way of constraining what the user can do and making them instantly aware of the limits of what they can do. I could set a maximum number of runs that the user can't exceed with this number input, but when they don't know that when they first load up this page, they don't know that I've maybe set a limit of 100 runs that they can't exceed. Whereas if the slider is there, they instantly know that that's the maximum number of runs they can do. They won't waste time trying things that we won't allow in the app. Like I say, there's different ways that we can display different outputs in the exercise. So we might want to display data frames. We might want to display charts. We might want to display metrics. So we might remember that a metric allows you to display just sort of like a single number with a bit of a label. So maybe we want to say actually in 3 out of 5 runs, we exceeded the ideal wait time on average. And therefore you could display that in a nice little card that is nice and clear for the user. Data frames, data frame columns. So there's lots of just reminders of the useful things from last week. These are just the slides from last week. We might want to arrange our outputs into columns. Again, that's absolutely something we can do here. So maybe here I want to have col1, col2, st columns. I'm going to have 2 columns again, remember, so you can do 3 columns. We just need comma col3 and so on and so forth. What I'm going to do with col1, my data frame is going to live in col1. With col2, my chart and the subheader are going to live in column 2. And now you can see, again, side by side, very quick and simple to start adjusting the layout of your app. Anything else that we want to take a look at? Tabs, you could use expanders. Another thing you might want to do is allow your app to use the full page width. I don't think that's something we need to do in this case, but there is a way when your Streamlit apps by default use about the middle half to 2/3 of the screen, you can make it so that they will use the whole width. The command for that is available in the slides. You could make it so that users could download the data frame. Maybe you could even make it so it interactively renames the data frame based on how many nurses were chosen, or some of the other parameters within the runs. So you've been provided with this same code, but just a little bit more advanced. It adds in the additional option to, in the model that you have for the exercise, it goes down those branching paths. So instead of just having someone turn up, seeing a nurse and leaving, your model has people turn up, they see a nurse, they go on to see a doctor. Some of them will need to go and book a test afterwards. Some of them won't. I think it might be a receptionist, a doctor. Some of them go back to the receptionist to book a test. Some of them don't. Some of them just leave at that point. So you might want to change the number of people who go on to see that nurse, or see that, go back to book a test. You have variation in how long it is between people arriving. You have variation in how long people are seeing the receptionist for, how long they are seeing the doctor for. So there's a large number of inputs, a slightly larger number of inputs that you may want to provide your user. Before you start trying to adapt the code, I would recommend doing like I did with this Python code and running it in an interactive window. Take a look at the output it prints. Don't worry, there's a huge number of different outputs provided. Like I say, you can gradually start to add them back in. Have a look at what output you think you might want to include in your app. Change those print statements into ST-write statements, see what you get out. Look at any Plotly figures and display them with Plotly chart. And you can then just slowly, iteratively think about how to display them better, think how to put them into these layout elements, and so on. So, as I say, what I'd recommend for now as well is copying the des code into your app. Don't try importing the classes. We will cover that later. It's a little bit more complicated. Just start like I did from this code and just start adding the Streamlit elements in. So I went to the very beginning of my code, my des code that was perfectly functional des code that I could run within VS Code, and I started adding the Streamlit bits into it. And so there's instructions here for what you want. We want you to allow people to change. You can place these parameters anywhere you want. You could put them in the main screen, you could put them in a sidebar, do whatever you want with that, and then start displaying some or all of the charts and summary values in whatever way you so wish. Make use of columns and tabs as you want. You could create some additional plots in Plotly Express if you want, or try enhancing the given plots in some way. You might not have time for that because it will take a little bit of time to get your head around what the plots are doing. But if you want to, and if you feel like you've reached the limit of what you can do with the layout, etc., do have a play around with the des code and see what else you can get out of it. You could also try going back to what we did last week and adding some buttons to download each table as a CSV. Now, at the moment, some of the groups ran into this when they were trying to download their word clouds. There is a bit of a limitation that you press the download button and everything will rerun. So just be aware of that for now, but we will go through how to fix that in a later part of today's exercises. So, any questions in the chat at the moment? Dan, anything you want to draw my attention to?
No, I don't think so. I think everything's been answered. But please shout if people haven't.
Fantastic. Cool. So in that case, I will set you all off into your groups. We will go until, I think, we'll go until 12:10, and then we'll come back and have a brief look at stuff for lunch. But if people are getting on and want to keep going with this exercise, we may even run this to lunch. I'll probably bring you back 5 minutes before lunch just to wrap up either way, but we will play it a little bit by ear how long we want for this exercise. I don't fully have a sense of how long you are going to need on this one, so we'll see how it goes. There is a Streamlit tech support room if your Streamlit is broken. I would generally, that reminds me of just a quick reminder of the GitHub code spaces. For anyone whose VS Code and Streamlit is not working for any reason, I would highly recommend that you go to the 7C web apps code, the repository, which I'm hoping is in here in my list, but the repository link is in Slack as per usual, and I will pop it in the class tannoy just as a reminder. What you will need to do is head in to the repository. If you are logged into GitHub, which hopefully you've all got GitHub accounts after the exercise a few weeks ago, the GitHub, the source control session, click on use this template and click open in a code space. Now this will probably take about 5 minutes to set up, so I won't sit here the whole time that it's loading. But what you will get is it will think about it for a long time, but you can see I'm now in a completely web-based version of VS Code. And everything you can do in normal VS Code, you can do here as well, including running code from the terminal. There are no environments to worry about because there is one environment and it's the right one for these exercises. It will, when you try and run Streamlit apps from the terminal, it will automatically be using all the correct packages. After this is finished loading, you'll need to give it a few minutes. Like I say, what you will see appear in this box on the left-hand side, the Web Apps Explorer, like just like your normal VS Code, all of the files that were available in the repository will appear here when it has finished loading. And you will then just be able to access and use everything in here, just like everyone else. And I would recommend that rather than trying to get Streamlit working if it's broken, because it will probably just take too long. But if you've got a small Streamlit niggle and you just need to pop in and have two seconds in the tech support room, I will be in there briefly. You can also use the call for help button and I will pop in and have and see what I can do for you. But do have a go with code spaces. Like I say, I will share the link to that in the class panel. Other than that, I think that is everything. So go away, have a look at turning the code in exercise 1. It's called des classes, this code, and it is just that model code. Just like we've been going through here, you just need to start thinking about how you pull in your inputs and how you display your outputs. Have a look through the code first. You've got plenty of time, and then see what kind of Streamlit app you can create. So I shall get those breakout rooms open. Hello, everyone. I think we've just got the last few people rejoining this main room. Yep, we've got everyone back now, I believe. So we will carry on, and before lunch, we'll go through a couple of the bits that we will be working on in the exercise after lunch. And there'll probably be a little bit more to go through just after lunch, just to get you ready to go on that one. So I hope you found that exercise okay. I think I maybe actually gave you a little bit too much time on that in some cases, but hopefully that gave you a really nice chance to just get used to using Streamlit, get used to laying things out, get used to working with inputs, and just hopefully that gives you a flavor of what it's like to take some existing code and really turn it back into something, or turn it into something that is a lot more user-friendly, rather than writing a Streamlit app from scratch, taking something that already exists, which you'll quite often be doing, and turning that into an app. So we'll go through a couple of things now that will hopefully A, make your app easier to use, and B, make it easier to work with apps as they continue to get bigger and bigger, and it also give you a way to split out a working Python script from an app. They don't necessarily have to be, something that you can only run in an app. So let's work through some of these examples until lunch. So the first thing I want to talk you through is how to control app execution with a run button. So you've probably found as you've started to add in more and more sliders and more plots that actually it's getting a little bit clunky. Every time you're changing something, everything's rerunning. It doesn't feel like the best user experience. And you will find that even more as your simulations get more complex, or any other elements of your app become more complex, it becomes really inefficient to have it rerun automatically every time a value gets changed. So what we can do is relatively simply add in a run button that will mean that nothing happens until the button is pressed. So what I'm going to do is I'm going to head down past all of my model code. I've got all my inputs up the top, that's fine, nothing needs to change there. Head down past my model, past my trial class, and all the way down to where the trial is actually running. First thing I'm going to do is just create a button that will allow users to press it. So what I need to do is create a variable, as with all of our other Streamlit bits and pieces, and I'm going to call this button run pressed in this case. st.button run simulation. Now, when I first load this up, what we will find, let's just get rid of that. There we go. I'm going to get this app up and running so you can see what's there. So we've now got this clinic simulation, and there's this nice big run button, but you can see that everything's actually already run. It's not doing anything, but we now have this button here. That's the result of this button run pressed code. I'm also going to switch to always rerun. I wasn't doing that previously, but I've heard a few people say that they actually much prefer to work that way. And I think it might be a little bit easier to see the impact as I'm saving this code left. So when you rerun, when you save changes to a Streamlit app, you will get this little always rerun option appear. If I click on this now, every time I make a change to my Streamlit code, it will automatically be reflected in the Streamlit screen over here. So if I now put this button in, I just took it out by commenting it out. If I put it back in and save, you can see the button has instantly appeared in my code over on the right. So how do I actually stop all of this running until I've clicked the button? Well, what we need to do is do if button run pressed, and I'm going to do a colon, and I'm going to indent everything that follows. So this, remember, is our trial.run file method. This is where it actually takes all of the parameters and does the calculations, does the simulations. So everything below, in this case, all of our plots, all of our charts, etc. I'm going to indent the whole lot. I'm going to save, and now you can see what I've done. I've got this here, I've got a run simulation button, and nothing is appearing. Now, as soon as I click run simulation, it all appears and everything has changed. If I now change the sliders, what you'll see is everything that was there has disappeared. I click run simulation again, we get the new outputs. If I change this down to one nurse so that we can see, we'll expect some really big queues here. We're down in the sort of 10s to 20s here at the moment. Change it down to one nurse, click run simulation again, then we change up to this having a much longer wait. So you can see it is reflecting those changed parameters. Now, how is this working? Well, remember, Streamlit again is running from top to bottom. So when I eventually find this button on the left here, so we have our Streamlit button. When this initializes, it initializes to false. It just goes, well, okay, you haven't pressed this button yet. It checks if the button's been pressed. It goes, it hasn't. So it doesn't do anything. As soon as the button is pressed, it runs the remaining code. The other thing we can do to make this work even more nicely is to add in with st.spinner and indent it another level again. So again, I'm just going to highlight all my code. And this is because when we run this and have a lot more runs, you will find that it starts to get a little bit user unfriendly. They'll click the button, nothing will seem to happen. They're not sure if clicking the button actually worked. Sorry about all this scrolling, trying to keep track of where I am. If I maybe just get rid of this lot for now, it'll be a little bit clearer and I won't keep ending up in all of this commented out stuff. So we've just got a couple of outputs. So now if I change this to 50 runs and press enter, run simulation, what you can see is we get this nice little in progress. It only was there for a second because, well, in this case, 100 runs isn't that many for this very simple simulation. Change it up to 150 runs. Run the simulation again. You get this nice little in progress slider, in progress spinner appearing. We've always got this run button up at the top right, this run indicator, but it's not as clear for a user who's actually kind of clicked in. They're expecting to see something in front of them, telling them that something's happening. So with st spinner, so we have if button run pressed, tells it to not run until we have pressed that button. With st spinner, adds in that spinner. The spinner is optional, but that additional thing will give you the additional value for the kind of user presentation. So let me just return to the slides. Yep, so the first line is making that button, then that line is making the spinner, and then anything inside that indented block will only execute after the user has pressed the button, and the spinner will disappear when it's finished doing all of those calculations. Next thing I want to talk about a little bit is splitting out your code. So you may have found already that you're having to do an awful lot of scrolling within your code. You've got this mixture of model code, web app code, and it's getting quite clunky. And of course, the more complex your app gets, the worse this problem is going to become. So what I've got here is my teaching starter code. I'm just going to, let's make a brand new folder here. And I'm going to call my nice des. Let's just do that for now. First thing I'm going to do is create a file that all of my des code is going to sit in, my actual classes, my model classes. So I'm going to do des classes.py, and I'm going to copy in all this stuff from the top, basically. So I want my G class, I want my patient class, my model class, and my trial class. So more or less all the things that you had at the very beginning of all of this when we first started out with our sample code. We're going to move that into this new file. So just to remind you, what's in here now is the G class, the patient class, the model class, the trial class, all of the code for that. You can see it's not too happy about us having no longer got the consult time and the number of nurses and everything, and the number of runs in here. So we'll just change these back to some defaults for now. We'll just put whatever we want. Let's have 5 nurses. Let's have a mean consult time of 15. If I were to run this app at the moment, if I were to actually just use, trial.model run trial, trial run trial, this code can now run by itself if we were to go in and make sure we've imported the code, the model classes, the libraries that it needs. What does this need? Well, it needs SymPy because we're using various SymPy functions within it. So I'm going to import SymPy. I'm also going to import pandas because we've used various things within here to make sure that pandas can create outputs of the model, the model runs, outputs from the model runs. So we've got SymPy, we've got pandas, and we need the random library because we do various random sampling bits. How do I know that? Well, I've got them in this code. It was also in, for example, the des classes. So what was in this starter code that I gave you? SymPy, pandas, and random. So these are my nice des classes sitting in my des app. I don't need SymPy and random in my app code anymore. But what I'm going to do is I'm going to create a nice app.py file as well. And I'm going to copy over the rest of my code into there. So now, just so that it's nice and neat in this new folder, I've got des classes containing all of the des code and the imports relating to running the simulation, your SymPy, your pandas, your random. In my app code, I've then got, I can get rid of SymPy and random. I can get rid of pandas. All I need is Plotly. I need Streamlit, and I need, Plotly and Streamlit. I'll move this NumPy over to, no, I do need to. So in this particular code, it's just splitting out what needs to run in the app, and it's mainly going to be your Streamlit and your plotting library. So now what's going to happen? Well, at the moment, this app, this file over here, my app.py, doesn't have any concept of, this app doesn't have any concept of what all this model code is. It's now trying to run the trial class, and it doesn't know what trial is. We haven't defined it within this file. The other thing we haven't done is tie up these sliders back to our G class. So we need to do some additional things. I need to be able to import from my des classes file the G class and the trial class. So what I'm going to do is create an additional file. This file is just called underscore underscore init underscore underscore .py. That file is blank. It doesn't need to contain anything. It just needs to be in the folder. It's a little bit complicated to explain why. So all I'm going to say is when you need to import some code from one Python file into another Python file, put the init.py, the blank init.py file, in the folder where you're doing the importing, and that will put you in good stead. So now I'm in my app, and I'm going to do from des classes, and you can see it's actually auto-filling this. It recognizes that des classes is something I might want to import. From des classes, which is what we named our folder, our file where we're keeping all of our des code, import, and I'm going to import G, our global class where we keep all of our parameters. And I'm also going to do import trial. Now remember, trial is a class, so it has an uppercase to start with rather than a lowercase. It's not a function, it's a class. So from des classes, import G and import trial. Now, if I run this, so I'm just going to open up a nice new terminal. I need to move into my nice des app folder, and I'm going to do Streamlit, run, and I need to run the folder where the file where I'm keeping all of my Streamlit code, not where I'm keeping my discrete event simulation code. So I'm going to run app.py, and now we have a nice app still working. However, if I run the simulation at the moment, for a start, it's going to tell me that NumPy is not defined. So I think that means I need NumPy over here, and I don't actually use NumPy in this app, that it's not actually making use of it. So let's rerun that, run the simulation, and you can see that our app seems to be working. Everything is coming through. But if I change the number of nurses now back down to 1, we're still getting very short queues. If I turn it up to 10, queues aren't really, it's still about the same thing. Again, we haven't linked this back up. So all I need to do now, rather than having this that we had before, class G, I don't want to do that here. I just want to overwrite the relevant parts of class G. So we're importing class G from elsewhere. I just want to remind myself what I want to override. So let's type in G. After I've set up my sidebar with my sliders, I'm going to do G dot number of nurses. If I went back to my des classes file, I'd see that number of nurses is one of my attributes of my G class. So I'm going to do G dot number of nurses in the correct file. G dot number of nurses equals num nurses slider. Then do G dot mean end consult time, mean consult time slider, and G dot number of runs equals number of numeric input. So again, this is just tying up what is provided in the des classes and what is provided in our app. And this time, instead of doing G equals number of nurses slider G, or number of nurses, we're not doing num nurses slider. We're not defining it like that. We are importing these defaults into this other file, and then we are overwriting them with what the user is passing in. So let's save that and rerun. And it's auto rerun because I've set it to auto rerun this time. I'm going to run my simulation. With 10 nurses, we have very short queue times. With 1 nurse, we have very long queue times. So it is effectively overwriting the defaults that we've defined over here and using the inputs. But the wonderful benefit of this now is you can see our actual app code is really tidy in comparison to what it was. All we have in here, rather than reams and reams of discrete event simulation code, is just the code dedicated to effectively the front end of our app and a little bit of interaction within the app. All of the code for the classes, the model classes, which we don't need to do anything with anymore, can exist over here. So here we've got the outputs, the plotly plots, etc., and everything else. The model classes themselves are now sitting neatly tucked away and are a lot easier to understand by themselves. So with 2 minutes until lunch, I'll quickly check if we've got any questions, and then we will regroup after lunch to go back through a couple of additional bits. So after lunch, we'll talk about how to actually split your app into multiple pages. And we'll talk about a couple of nice little things like making your app look prettier, which everyone always wants, logos, and also using some custom theming code to add in additional theming things that you can't generally do in your in Streamlit without a little bit of additional know-how. So I think that's everything. Just checking the chat, maybe answer in a second. When you change a slider on the sidebar, it removes all of the previous run results under the button. Yep, so that will continue to happen for now, unless we start working with something like session state to keep some of the memory of what's happened in previous runs. So for now, that's a sort of desired behavior. After you change the slider, you want it to remove all the previous run results that were under the button, because otherwise it can be a little bit confusing to the user to go, oh, well, that must be the updated results. So you just want it to disappear ideally, and then they won't reappear until they click run again. So, right, I think go and take some lunch. And we'll regroup at 1:30 and go through those additional bits before we send you off on another exercise. So see you guys a bit later. Hello, everyone, and welcome back after lunch. I hope you've had a good break and had a bit of a chance for some of the stuff we've been discussing this morning to settle in a little bit. So I'm going to kick off fairly quickly now. We've got still quite a lot to get through this afternoon. So I'm going to talk now about multi-page apps. So as your app becomes bigger and more complex, it can be really beneficial to split it out into multiple pages. This is better than just splitting it out into multiple tabs. In some cases, tabs can be very useful, but multiple pages can be really valuable for making sure that you don't end up with huge amounts of code to sift through on a single page. Also for making sure that you don't have huge amounts of stuff running at once all on one page, remembering that top to bottom execution. So when you run code on different pages, the code on the other pages doesn't run. So it can be a very efficient way of splitting out your app. So what we can do with this, or one of the downsides of this, is it does mean that things created on one page can't be used on another. So you need to think about that when you're setting up your multi-page app. This can be overcome with session state, which can be a really valuable way of using session state. We'll talk about this in the next section. But for now, just bear in mind that by default, things that exist on one page in your app don't exist on the other page. They're almost like two entirely separate Python scripts. They just happen to be running within the same Streamlit app, and you can move between the two. So there's a few supported ways to set up multi-page apps. This is still a relatively new thing in Streamlit, and therefore you might find some of the old ways done in the within the documentation. So if you look at the Streamlit book, it does go through both ways that are recommended for approaching this, but I'm going to talk through the way that Streamlit now recommends you do this. Just be aware, you may come across some different ways of doing it when you're looking at Stack Overflow, old Streamlit forum posts, that sort of thing. So I'm back in my nice Des app folder, the one we created just before lunch. If you recall, we now have an app.py file, which imports Streamlit and Plotly, and also imports from our Des classes file. And then this is where we are doing all of the things like setting up our sidebar, setting up our imports, and so on, and actually running the code. We also have our Des classes file, where we are importing things like SymPy and NumPy so that we can do the simulation and run calculations on the output, and also so that we can store things like our classes in here. So this is just keeping this nice and separate. What we now want to do is create a third file. So what I'm going to do is I'm going to actually rename this one app.py to, let's call this simulation page. So this is where we are actually going to be running our simulation. I'm also going to create another one called homepage. It doesn't have to be called that, it can be called whatever you want. But here I'm just going to do something like import Streamlit as st, st.title, welcome to the simulation app, and st.write, here's loads of information about what we're doing. So if I were to run in my terminal, I'm just going to jump into the right folder. So if I were to run Streamlit run homepage.py, this will load up over here for me. And we just got a very simple app that says, welcome to the simulation app. Here's loads of information about what we're doing. If I close this one down and do Streamlit run simulation page.py, we now get our simulation just like before. So at the moment, we now have two completely separate Streamlit apps sitting in this folder. What we need is a third file that will allow us to link them all together. So this one, I'm going to create and call app.py. Now in app.py, I need to, again, import Streamlit as st. And then I'm going to use the Streamlit navigation function. Within the navigation, I need to pass a list of pages. So within our list, we have two Streamlit pages that we want to be able to access. st page, need to put these in quotes, homepage.py, that's the first one we want to appear in the list. And on the second one, we're going to do st page, simulation page.py. I'm going to save that. Now, we also need to actually run the app when we open this file. So we need to do a couple of additional things. We need to do PG, or whatever we want to save this as, something like pages, my pages, but the standard in the app is, the standard in the documentation is PG. Then we just need to do pg.run. So every multi-page app that you create will have a file like this. It will import Streamlit. It will create this list of navigation, which is a list of Streamlit page objects referring to the names of the files that we've created. And then it needs to do this pg.run. So now, if I do Streamlit run app.py, you can see that we now have a list on our left-hand side of two different pages that we can navigate to. So I click into here, the simulation page loads. I can now click back to the home page and welcome to the simulation app, loads of information about what we're doing. So nice and simple to add as many pages as you want. I could go through and add 30 pages this way and it would work absolutely fine. It's a very scalable and simple solution in that way. Now you see we didn't have to import or do anything extra with our desclasses.py. Remember, that is just where we're storing the actual classes for the simulation. So that doesn't have to come into play here. But we might want to tidy this up a bit. At the moment, we've got home page and simulation page. It's not very user-friendly. So let's add in a title to each of these. Welcome to the, let's just call this welcome. And I'm just going to add simulation. Clinic simulation, let's call it. I'm going to save, going to rerun, and you can see now we have our titles in this sidebar have updated. Now you might be going, well, that's all well and good, but I want to use the sidebar for my inputs. Well, you still can, that's absolutely fine. If we head back to our clinic simulation, you can see that under the list of pages that it's automatically populated, we still have our sidebar from earlier with all of the simulation inputs. So just be a bit mindful that you will have some space taken up at the top with any navigation that you want, but this does allow you to have more space. And this could be a really good way of having different complexities of clinic, different kind of clinic layouts, that sort of thing, across a couple of different pages, or anything else where it's starting to get a little bit complex. And you can see that our actual individual files now are really a lot nicer to work with. We have this nice little neat just you know, a couple of bits of text. You might have some images, you might have a flow chart of what the actual simulated clinic is, that sort of thing, some contact details maybe so that people know who to come back to if they've got problems. Then the simulation page is no longer cluttered up with loads of DES code. It's just a lot easier to read and understand what's going on. The other nice thing you can do with these is actually start to add in a couple of icons. This is not quite so intuitive, but just to show you, and this does get covered a little bit more in the book. If I were to do icon equals, and the easiest one to pass in is what's called a Google material icon. It's a library of icons that's available on the internet, and we can look up the different values that are available. But just to demonstrate what this looks like, it means that you will, if you correctly define the emoji, you get a nice little icon to the left of your pages. So that can be really helpful just if you want to, you know, have a little computer icon next to your clinic, that sort of thing, or just make it a little bit easier for people to navigate as you go on, just adds a little bit of polish. So next thing to talk about is, I'm sorry, Zoom has hidden everything again. Next thing after multi-page apps is theming. So what we want to do here, I'm going to show you how you can make your app look a little bit nicer. If I were to head into these, well, I'll rerun first just so that we've got the most up-to-date version of the app available. I'm going to click on these three dots and choose settings. And then I'm going to edit active theme. Now what you can see here is we've got a primary color, we've got a background color, we've got some text color and a secondary background color. So the secondary background color, for example, covers the color of the sidebar. Primary color you can see seems to relate to these icons. So I'm going to click in and I'm going to change these to whatever I want. And you can see as I've clicked out of this color picker, the color of these sliders here is changing. The background as well, let's change that to a light blue. Let's change the secondary background color to a yellow for now, just so you can start to see what's happening. And the text color, let's change that to black so we can see it a little bit more clearly. So I wouldn't necessarily say this is a theme you'd actually want to use, but you can use this interactive theme editor within your app, and then you can save the theme it creates, which makes it a lot easier than trying to define this theme yourself. Within our app folder, we then need to create another file, another folder, a subfolder called .streamlit. Has to have that dot at the start. Within this, we create a file called config.toml. We copy the theme to the clipboard and we paste that in. We save our config.toml file. And now if I refresh this app, you'll see that it doesn't load. And the reason that is because we need to reload from the start. So actually, after you first save that config.toml file, it doesn't get loaded in until you start your Streamlit server again. So I've closed my app, Control-C, closed it in the terminal. I'm just going to do Streamlit run, and I'm going to run my app.py. Remember, we're loading in app.py now. That's the one that controls all the navigation. And when I run this, we now have that rather lurid simulation theme. So that's a really easy way, and you can look up things like the NHS style guide to make sure that you've got colours that work for your organisation. The NHS style guide has some really nice defined colours that are known to work well together. Do be aware of things like colour blindness when you're trying to choose your colour palettes. And also just be aware of things like contrast of the of text on top of coloured backgrounds and the like. So just use your best judgment and don't make things necessarily look like this. But that is just into, if I were to open this slot up in a file explorer at the moment. So remember, I'm in my Nice Des app, and what I have, if I can make this a little bit bigger for you to see, we have our app.py, our des classes, homepage, simulation.py, our init.py, remember that blank file that's just allowing us to import the des classes around. Then we have this subfolder called Streamlit, and we have config.toml inside it. So .streamlit, config.toml in there. Also note that when you import things between files, so when we're importing the des classes into our app, it is automatically creating this PyCache folder. You don't need to worry about that. It's just something that automatically gets created, and don't think too much about it. It's just there. So next thing to talk about, I think we're nearly there on this section. Logos, so you can also add logos to your app. The shame is that they don't allow you to add very big logos by default, and the workarounds to create big logos are a little bit prone to breaking as Streamlit gets updated over time. You might have noticed that in a couple of the examples that I showed at the beginning of last week's session. However, we can still add a nice little logo at the top of anything that we want to. So let me just remind myself of this. I believe the rather nice thing we need is just ST logo. So I'm going to add that at the top of my homepage, st.logo. And actually, I need a logo. So let's go into exercises, exercise 2, HSMA logo. This should be in the right format for today's exercises. So I'm going to copy that out. I'm going to pop it in my Des app, right-click copied, right-click paste. That's now sitting in my folder with my app.py, my desclasses.py, and so on. So all I need to do now is just do st logo, HSMA logo.png. And if I save this and rerun, then you can see we've got a little HSMA logo up the top here. If I move over to the clinic simulation, that logo is gone. We need to make sure that we add that to every page on which we want it to appear. So we've now got a simulation page. Let's just pop that in there as well. So you might need to do a little bit of fettling with whatever logo you have that you want to be able to add in, but you could add a small little NHS or Trust logo up there, or whatever organization you were working for. Final thing in this section is custom cascading style sheets. So when you get to the limits of the theming you can do within Streamlit, so for example, let's say when I go into settings and edit active theme, you can see that I can change the font family. I can change it to a sans serif, so it doesn't have the sort of little end caps like you might have in Times New Roman. I can change it to serif, which gives it this slightly sort of older fashioned looking font. I can also change it to monospace, which gives it a very kind of standard coding sort of feel. But that's the extent of my customization for fonts. Nothing more than that, which is a little bit unfortunate. So what I want to be able to do is import what we call a custom CSS file. Now, this is just another bit of sort of web language that allows you to do various bits of theming. Most of you probably won't want to go into this too much, but it's good to know it's an option for if your stakeholders do start coming to you and going, well, I need it to look exactly like this. There will be various CSS tricks and tips mentioned on the Streamlit forums, etc. There's always people asking about how to do more advanced things with styling. So I'm going to go for style CSS. So in exercise 2, you don't need to worry, like I say, about exactly what is being provided in this style for this particular example CSS file. What it is basically doing is importing a font from Google, and then it is applying that font to all of the text on our app. That's it. That's saying header 1, so the big headers, header 2, slightly smaller headers, header 3, and so on. And this is also telling it to use it for the general text on the page. So you can use this as a starting point if you ever want to customize yours further, but this for now just brings in the font that we use for all of our HSMA materials, Lexend. There's also one, I believe, called, I can't remember the name of it off the top of my head, but there is one that is very similar to the standard NHS font, which you might want to use for your own apps. And I can provide a link to what that font is called so you can adapt this CSS file accordingly. I'm going to copy this CSS file into my Des app. So we can see our folder's getting bigger and bigger here. And then the only thing I need to do is import that into, again, each page that I want to use it in. So my home page, for example, I will need to import this CSS. And I'm just going to quickly remind myself of the code because it's one that I just have to copy and paste every time because I don't need it very often. Once you've copied it in once, you can just copy and paste it around all of the places you need it. And that is basically the way I would recommend doing it. So if you head into fonts in styling here, It's just this little code snippet. All this does is look at the style CSS file, and it puts it into Streamlit's actual code. So every time a Streamlit app page is initialized, it will then inject this code into the top of the HTML file. So what I'm going to do here, I'm going to save that. I'm going to copy that also into my simulation page, nice and near the top. The nearer the top you put it, the better chance that it will work for everything on the page. And now if I rerun my simulation again, take good note of what these fonts look like. And hopefully when we rerun, you can see that the font has changed quite significantly. So we've now got this much wider, chunkier, well, sorry, it's a wider font, but each letter is a little bit slimmer. I get rid of this again, save, rerun. You can see it goes back to that slightly chunkier standard Streamlit font. So it's not essential, but it's a really nice way to start making your app not look like every other Streamlit app, because you do get to the point where you get a bit of Streamlit overload. It's just one more Streamlit app. So actually adding in these little touches to make it look more like something that's an NHS app, more like an app that fits your organization's style guide, an app that has a font that isn't the same font as everything else. It's not essential, it's just nice. So what I'm going to do now is stop sharing. But before that, I am going to just quickly let you know what we're going to do in this next section. So it's time to enhance your Des app a bit. We're going to work on this only for about 25-30 minutes. We'll play it a little bit by ear, depending on how you're getting on. What I want you to do is head back to the things we did before lunch. I've added in some slide references to hopefully make it a little bit easier to keep track of. First thing I want you to do is add a run button so it doesn't run each time you change a slider, so that it'll actually only run when you click. Next thing I want you to do is split your code out into those separate files for the web app and for the Des classes. So import your Des classes into your web app, run your web app, and make sure you update how the G-class files, the G-class parameters are set. That's all recapped on slides 45 to 48. Finally, I want you to make your app into a multi-page app. I just want you to create a nice, simple page that, a bit like I did here, just a homepage.py or something that just says, hello world, something like that. Doesn't really matter what's on it, but I just want you to be able to practice setting up that navigation and moving between different pages. So if you get all that done, then please do have a play around with creating a custom color scheme, adding in the logo. It's provided in the exercise 2 folder. And if you want to do that importing of the custom CSS as well. Any questions, Dan, before we kick off on the exercise?
I don't think so. Nothing that hasn't been answered. A bit of discussion about the NHS fonts and everything. Apologies, I got lost through my own fault halfway through because I realised I was I deleted the wrong files and then completely buggered up my directory. But just looking through, I don't think there's anything. The only thing I was going to just flag up, I mentioned. So obviously you put in about the config. You can set up your own sort of config. Little tip that I found: if you just want to force either a light theme or a dark theme, you can just use theme and then base equals dark or base equals light in your config file, and that will force that theme for anybody that watches it. And I've, as a dark theme user, I have forced that in my app. Well, it's not working at all now, but when it was working, that's what happened.
Yeah, no, definitely. Yeah, that's a good shout, actually. It's because otherwise, by default, I think when the user chooses, or when if you don't otherwise specify in a config toml file, what will happen is the default system setting will get used for the app. So actually, you might find that the app doesn't get displayed quite as you're expecting. It might default to light, and if you're a dark theme user, then you might find that everyone else's experience of the app is very different to yours. So it is good to set a default, I would say, although it's also nice to let people choose. So just be aware you might also want to play around with seeing what it looks like under different settings. Brilliant, thanks, Dan. Cool, right, I shall stop sharing and I shall put you into your breakout rooms. We'll come back at, let's say, if I can do some maths, 1/4 no, that's not right. I'll put it in the chat when I've had a bit more coffee, but we'll work on this for just about 25 minutes roughly, and then we'll come back and do some super advanced fancy Streamlit bits and bobs. So see you in a bit. Hi everyone, hope you found the extra little bit of time useful there. I could see that a few groups were kind of nearly there or just about to do the multi-page stuff, so just wanted to give you a little bit of extra time on that one before we went to the next bit. So I'm going to go through two bits now, caching and session state, and then we'll take a bit of a break, have a breather, come back and go through the last two bits, have a look at that exercise. And then at the end of the day, we're hopefully going to do a fairly fun bit, which is just getting an app deployed onto Streamlit Community Cloud. So what we're going to go through now are the slightly more complex features that I would say are sometimes incredibly useful for your apps, but when you are first starting out, you won't necessarily need to use them. It's just very useful to know they exist as your app gets more complex. If you could do with actually, you know, if this is a bit much today and you just kind of want to listen along now, but carry on with the previous exercise when we take some time to try out these bits, please do feel free to do that. There is a lot to take in again today. You're working with quite a lot of code, quite complex code, but hopefully you will find these additional features quite useful. So the first one I want to talk about is caching. Now, when we're loading data files into Streamlit, you will run into a couple of issues. So when you've got a big data file, each time you are doing something within your app, so let's cast our mind back to our penguins data example, we are trying to filter the data frame, for example, maybe we want to filter by the species of penguin that we have, then everything in the entire app is rerunning every time we make that change, including loading the data in. The data hasn't changed. The data is entirely as it was. And also every single person, when we start loading this up onto the Streamlit Community Cloud, every single person is loading in this data into memory, even though everyone is accessing, in this case, exactly the same data. Not much of a problem when you've got 300 lines of data on penguin bill measurements, takes up very little space. When you start loading in, for example, very large geodata frames, you can very quickly start running into problems. And it can also make your app just feel incredibly sluggish. So if it's reloading this huge 20 megabyte data file in every single time, or bigger than that even, then every time your user interacts with the data, it's going to feel really slow. It's not a nice user experience. The good news is Streamlit's actually really clever about dealing with this. They provide you with a relatively easy way to get it to control when it should reload the app, when it should reload the data. And it will intelligently decide whether it needs to reload the data now or whether it can use some data that's already got stored in memory. And this will really speed up your app. And especially when you get to deploying and trying to get multiple people interacting with it, it will really help out there as well. So the main thing here, for example, I'm going to get rid of all these additional bits for now. I'm back in my penguin data, and all I've got is I've loaded in Streamlit, I've loaded in pandas, and I'm reading in my penguin data frame. Now, if I do st.data frame, and I will run this app. There we go, that is loading up. So in this demo, you can see we've just got our penguins data frame exactly like normal. Now to cache this data frame, I just need to turn my data frame import into a my data frame import into a cached function. So I do an at st.cache data. Now this looks a little bit strange, something called a decorator. I won't go into what that actually means, but just before I define a function to load in my data, I need to add this thing to tell it to cache it. All I'm then going to do is go def load penguins data. Remember, this is defining a function that is going to load in our data. You might not have written a function for a little while at this point, but def is just saying, I want to create my own custom function that every time I run load penguins data, loads in the penguins data. What I'm then going to do is I'm going to return from this, if I can spell return, I'm going to return the result of reading in this CSV of data. This CSV of data in this case is sitting in my folder. So I'm just going to return the result of PD read CSV. And then when I define my data frame, I'm going to do load penguins data, my function that I've just defined. I need the two brackets after it, but I don't need to put anything in there. This function doesn't require the user or us to tell it any particular parameters. It's just loading in the data, but we need to put it in a function because otherwise the caching won't work. And now if I save this and rerun, the user has no idea that anything different is happening in this case. If this was a much bigger data frame, we would see a much bigger impact. But for now, it doesn't really make much difference. As I say, it's a very small data frame. When you work with the data in the exercise, which is a 20-odd megabyte geodata frame, you will see a lot more impact of this. So what else do I need to tell you about caching? Like I say, without caching, it's just PD read CSV. Loading in the same data set with caching is just turning it into a function and then running our function and saving that as our data frame, as the variable we were using. So it's very quick and easy to change over to caching. Once you've initially set up your app, you don't have to think about doing the caching from the beginning. Just do it like you've been doing already and then add in the caching later if you so wish. Caching is really clever in Streamlit, but there are two different types. There is data caching and there are resource caching. The resources tend to be things like machine learning models. So it can, again, make sure that it's not reloading the same machine learning model. And again, they can get quite big for every single user. But most of the time, if you're doing charts, data frames, strings, integers, anything like that, the results of long calculations, you will probably just want to use cache data. And the main benefit most of the time is for loading in data sets initially, but it can also be really useful if you've got particularly long running calculations that you might want to also save the results of. Now, you can also pass in parameters. So I said when we were doing this one over here that we didn't pass any parameters into the function, but maybe we wanted to pass in something like a species so that we only load in or we automatically filter the data for that particular species and return that. You can absolutely do that. And again, it will look intelligently at the arguments you pass in to this function that we define and go, do I need to load this data in again? Or have I already loaded this in with these parameters? Or have I already done this calculation with these parameters? So again, not something you need to worry about generally, but it's useful to know that you can add in that additional layer of complexity and Streamlit will understand whether it has loaded that exact data or done that exact calculation. Now, it might be that you're connected to, say, a database and you know that the database refreshes once every 24 hours, something like that. So you can make sure that Streamlit will only keep the cached data for so long. And if it looks at the data and goes, I haven't reloaded this in 6 hours, 8 hours, however long you want to specify, 5 minutes, then it will reload that data. It will clear out the cache and reload in again. That's an optional parameter that you can set in if that is relevant in your situation. The other thing you can set is the maximum number of entries. So if we did have, for example, a calculation that we wanted to cache, so the outputs are cached, it's a long calculation, maybe we want to store perhaps 10 different possible combinations of that cached function. But after that, it starts taking up too much memory in our app, and we just want to start dropping off the last one that was used. So we can set what's called the maximum number of entries, the maximum numbers of data copies, etc. It will store in the cache before it starts making way for new examples. So again, this is just a way to make sure your cache doesn't get out of hand. You don't need to worry about max entries and this other one, time to live, the one where it will get rid of older time entries, unless you're really getting deep into caching, but it's very useful to know that those options exist. And the next thing I'm going to talk about is session state. So one of the things I've mentioned about multi-page apps is that variables don't persist across different pages of the app. Once you switch pages, all of that information is lost. And the other thing is that you can use this to remember things across multiple pages or multiple runs of the same app. So you can transfer information between those separate, almost Streamlit apps that are sitting within your multiple pages. You can also, if you were, for example, doing a discrete event simulation app, you can save the output of a particular run, kind of say, maybe you might want to save that actually with this particular example with 5 nurses and an average time of 25 minutes for the consultation to run, then actually this is what the results were for that. Then your user changes the parameters, runs it again, and what they get out is that data. So they know what happened with those particular set of parameters, but they can then start to compare it against the new parameters. And I'll load up an example of this in just a second. But session state is your way to have memory within your Streamlit app across pages and across runs. So let me load up an example here. Let's head back to My Nice Des app. So this is the one where we've split our app up into multiple different parts. We've got our Des classes, we've got our app, we've got our home page, and we've got our simulation page. Now, at the moment, if I was to do something in the simulation page and let's say, what are we getting out in this example? This data frame. So for example, this mean results data frame. If I wanted to try and use something out of that mean results data frame on the home page, I would have absolutely no use. If I wanted to take actually an input, this might be a better example. Let's do, here we are, number of nurses equals ST slider. Please enter the number of nurses. Let's set a minimum of 1, maximum of 10. So I'm going to run the correct file. So loading up here. My total number of nurses. So I've saved this to a variable called number of nurses, starting at 1, maximum of 10. There we go. Let's set it to 85. Now, if I was to get rid of this from my actual simulation page at the moment, we're setting this up in the number of nurses slider. Well, actually, we've just moved that to the first page. For whatever reason, we wanted to do that on the first page before they get to the simulation. We want all of the inputs over here, for example. So now, if I try to run this, we've created the num nurses slider variable over here in our homepage. Oh, well, let's call it the same thing just for making it a little bit easier to keep track of. So over here, we have num nurses slider in our homepage. Over here in our simulation page, we have num nurses slider, and you can see it's already telling us that it's not defined anywhere in this map, anywhere in this page. So we've set it, great. But over in the clinic simulation, we'll be told that the num nurses slider variable is not defined, even though we've just made it over here effectively. So how could we make it so it passes through? We need to set up the session state. So in our homepage, or any page where we are creating or reading information that we want to be sharing between runs, sharing between pages, we need to initialize the session state variable. So we do if, let's call this num nurses slider is not already in our session state, we set up what the value should be. So st session state, let's call it num nurses slider. And here we'll set it to a default value of 5. Now I need to do the same over here in my other simulation page. I need to make sure that if the user were to jump straight into the clinic simulation page, if they had saved it in their favorites or something, that actually the app isn't going to panic and go, I have no idea what the variable number of nurses slider is. I can't use that. I don't know where it's coming from. So we set it up over there as well. And the final thing is now, when we want to use it, we will need to do 2 things. We will need in our home page to make sure that's what we're writing to. At the moment, we're writing to a variable called number of nurses slider. That's not our session state variable. They've got the same name, but they're slightly different. So it's important that we actually use this. So now we've got st session state, number of nurses slider. We are saving it to the shared session state variables, but it's still otherwise the same. We're still creating our slider in the same way. Then the only difference is when we want to use it in our simulation, we need to read back from it. So actually, where we were defining the number of nurses, we're using the st session state variable. So let's rerun this now everything's been set up. Now over in the clinic simulation, we know that we have a default of 5 nurses set up. So I'm going to run that with 5, and that's what we're getting, queues of about 140 minutes. If I go over back to my welcome and set it down to 10 nurses, we would expect the queues to be shorter. So clinic simulation, there we go, much shorter queues. And actually, to make this even easier, let's make a nice print statement. So after my title, I'm going to do st.write. I'm going to do an f string. You set sessions, the number of nurses to, and again, I need to use st.session state and then the name of our variable, num nurses slider. Now this is going to complain at me actually, because you can see I've got double quotation marks there, double quotation marks there. That's going to get very confusing. So let's just make sure we use single quotation marks. Rerun. I've set the number of nurses to 10. That's behaving a little bit strangely, but I'll explain why in a moment. But we've now set the number of nurses to 8. You can see it's remembered. We've set the number of nurses to 8. Go back to here, number of nurses to 2. It's remembered we've set the number of nurses to 2. Now, why is it behaving a little bit strangely when I'm moving back and forth? Well, that's because the default for the slider is still 5. It's not using any state, any memory for that. It is setting the default to 5 every time we load this page. So just be aware of that. But as we move to this page, as I do that, it's gone right, session state, that's 9. Okay, pass that over to the clinic simulation page. Great, we can use that now in our code. So it allows us to pass this around. The same thing can be true of running it within a simulation. So if we now ran this app, and I'll talk about this more after we take a bit of a break, but if I run this app, that session state variable will still be remembered. And the same is true of anything else that we save to the session state. Rerunning the app will not clear that session state. So let's take a 10-minute break. Let's take 10 minutes now, and then we will come back and do a little bit more on the more complex end of Streamlit, and then we'll do another exercise where we'll have a bit more of a play with caching and session state and so on, so you can get to grips with it a bit more. So I will see you shortly, and then I'll go through any questions when we come back from break as well. So see you at just after 3 o'clock. Hello everyone, welcome back. So session state, just going to wrap up that little bit about session state by giving you a demonstration of an instance where I think session state really comes into its own within a discrete event simulation context. And so what we've got here is our discrete event simulation playground. This is an app that we can that you may have interacted with if you came along to the open day for HSMA. But what we have here is a simulation like you've done today. Users can change a number of things and they get a load of outputs. Now, if the user wanted to compare, as I say, one instance with another, what happens if they do change to 6 cubicles? What's the impact of that? As soon as they click this run button, their previous run details, the previous outputs are completely lost. You've probably been experiencing that throughout with all of your code. They click run, everything disappears. So if they were then to try and change up to 6 cubicles, for example, 7 cubicles, and see the impact, they're going to have to either downloaded some stuff from your app. Maybe you've given them a CSV, or maybe you've turned it into a PDF that they can download. They might have actually just having to sit down and write down what on earth is the output. Okay, what's the value if we get this? Not necessarily the most user-friendly interface. So the session state can help you save results from a run, like a model run, a trial output, etc., to Streamlit's memory, so it understands or remembers and can still access it after you click that run simulation button again. Now, without using session state, those variables are lost, gone to the wind every time you click. With session state, these will be remembered by Streamlit until the user fully closes the app or clicks reload. So I've already run this once whilst we were on break, and I've saved the outputs for running with the defaults, but with 4 cubicles. I'm now going to change this up to 7 cubicles, and I'm going to run the simulation again. Now, this is going to take a little bit longer to run. One thing to note here as well, this is a nice little thing you can do. You can see our little running man, who's usually up at the top right. There's just a little bit of custom CSS here. So remembering that custom CSS from before, where we were changing the fonts from the default, you can also use it to do things like this, move our little running man to the center of the screen. So it's a lot more obvious that actually something is happening behind the scenes. So now if I head over to compare scenario outputs, you can see that we have scenario 1 with our 4 triage cubicles, scenario 2 with our 7 triage cubicles, that value that we changed. And we can start to do things like comparing the results from different scenarios. You can see that the triage weights here, the triage utilization is much shorter in scenario 2. And the triage weights are shorter because, again, there was more triage cubicles available. So that can be a really valuable way to use that session state. And you can start to see how this can come into your Streamlit apps, particularly in a simulation context. So it's got those 2 main uses: passing things back and forward between pages and saving things after the user has clicked the run button again. So, last couple of things to talk through. Callbacks are similar and related to session state. They are custom functions that execute when a user interacts with an input in some way. So one quite useful one for this, well, I say useful, one example where you see it used a lot is incrementing a counter every time a user clicks on a button. In normal Streamlit, that would be completely impossible because every time you click on the button, it would forget that you clicked on the button. So you need to store this in Streamlit and run a little custom function that goes, every time the user clicks this button, add 1 to a session state variable. So in this case, we've initialized our session state variable just like before. We've called it button click count. We've checked whether it's in our session state already, and if it's not, we set it to none. If it is already in the session state, if the user's been on a different page, for example, where it's already been initialized, or if they've already run the app page whilst, within the same sort of overall Streamlit session, they haven't closed the app, they haven't refreshed it completely, they've just kind of clicked something and it's rerun, then it won't overwrite with none. It will remember what the value was. So we then define a special function that does something on an action, whether that's a user interacting with a slider, whether that's them entering something, whether that's them clicking on a button, as in this case. This time we call it button action, but we could call it whatever we want, on click button, something like that. And we add 1 to our session state variable that we just defined. We then need to associate the callback with the relevant input. Now, everything like an ST button, an ST text input, an ST slider has either an on-click or an on-change argument. You will have to look at the documentation to work out which is which, but generally something like a button has a on-click parameter that is optional, where you can assign one of these functions to it. What that means in this case is every time the user clicks the button, this function activates and it adds 1 to the button click count that is stored in our session state. And then we can use our session state variable however we want to, as in this example here. So every time the user's clicking this button, you can see the counter is incrementing. We've passed that into just st_right and said, you've clicked the button 1, 2, 3, 4, 5, 6 times. So if you're getting into the point where you are using session state and callbacks a lot in your app, they are very powerful, but I'd really recommend having a good look through the documentation. There's a lot I haven't been able to cover today, but these can really get around a lot of the limitations of Streamlit apps that used to exist. Final one I want to go through today, the final bit of more advanced stuff before we then leave all of Streamlit's actual functions behind and move on to deploying your Streamlit apps, are partial reruns. Now, these are a fairly new feature, but what they allow you to do are break out of this sort of start to finish, top to bottom rerun pattern of Streamlit. Now, this is something that's kind of Streamlit got criticized for a lot in the early days, that there was no way to actually just run just this little bit. I'm changing this slider. It doesn't affect that graph. Why does it have to reload that graph? And that was just the way Streamlit was designed to run. It makes it very user-friendly to start up with. That's the joy of it. That's why I hope people enjoyed using it. But it did mean that there was this limitation that everything just had to run every time anything changed. Now, fragments, also known as partial reruns, allow you to get around that. Now, it's very much like the caching that we were looking at just before the break. You need to decorate a function with this @st_fragment, and you turn whatever the group of inputs and outputs you want to just keep boxed up together are. You put them in a function, and then when you want the function to actually happen or be used in your code, you just call the function. And then it will spit into your code your inputs that you've defined, things like your select box here, we've got, and then a plotly chart, and it will pop that into the relevant part of your Streamlit app, and it will only rerun that bit if something in that little fragment changes. So here, it will only rerun this plot if these particular drop-downs change. I'll show you this here. So without partial reruns here, without fragments, every time the user is changing something, what we're getting is the whole thing is rerunning. You can see that we've got this little running man, everything's grayed out, and the whole app is running from top to bottom. So I've changed over here, the penguin species to filter by. That hasn't affected this graph at all, but still it's rerunning the whole thing. Now go over here, change this bill drop down, rerunning the whole thing. And you can see it's reloaded that, no reason for it to. Here we've used the st_fragment decorator. So what we'll see now is we've changed chinstrap. This half of the page hasn't grayed out. It's not reloading it. This time we've changed the flipper length drop down. This half of the page didn't reload. Nothing changed in it. So over here on this side, we have one fragment, and we've defined it as a bar chart, something like that. And we've put in our select box, this select box drop down here, and we've put in the chart. Over here in our second fragment, so it's another function with the st_fragment decorator, we can call it whatever we want, but we've got a couple of inputs, 3 different inputs, and a plotly chart that should update if any of these inputs change. Then later in our app, when we're ready for them to go in, so we're here, we've got them in columns, we can just call the function that we've defined. This bar chart in this case, and this scatter plot, we've put them into columns. You don't need to make huge changes to your code to group it together to get it to run in this valuable, more efficient way. So what we're going to do now is try and have a play around and make our app really powerful. I'm going to provide you, or I've provided you in the exercise 3 folder with a new additional Streamlit app. that works out the estimated demand for an area given its demographic features. And then we're going to incorporate that into our main app. I'm going to take a quick look at the Streamlit app we're going to work with. So I'll talk you through what it's doing, and then we'll talk through what we're going to do with it. A couple of questions have just come through in the chat. So what marks the end of a cache or a fragment block? Let me just bring up the actual code for that example, and I will show you in a bit more detail. So this, the fragment stuff is in code examples, partial reruns, and it has the same code with and without the partial reruns. So let's put these side by side a second. Now, we have, in this case, the st fragment for the bar chart and the st fragment for the scatter plot. Now, the fragment stops effectively where the function stops being defined. As soon as you're out of this level of indentation, you're not in the same fragment anymore. It's all part of this one function that you defined. Same over here, we create a penguin scatter plot function. All of this will exist within the function. The st fragment, because it is indented within that function, and the fragment is attached directly to that function. You don't want gaps, nothing like that. It needs to be at st fragment, straight into the function you're defining. Then over here, we have the app column, penguin bar chart, and the second column is penguin scatter plot. So in our first column, which we defined in the normal way up here with st columns, we end up with the penguin bar chart, and all of that will go in on the one half, the species select box. It will do the actual filtering, and then it will create the plotly chart. Then on the right-hand side, we have our penguin scatter plot with 3 separate inputs. It does a little bit of extra jiggery pokery to make sure that the user can't plot bill length against bill length. That's what the extra code is doing there. And we output the plotly figure. So 1 def per fragment, I would say yes to that question. Does this mean only 1 def per fragment, 1 function per fragment? You could probably nest functions within it. So if you needed to define a function elsewhere and call it, then I think you could do that, but I wouldn't want to say for sure off the top of my head. So next thing, where were we on that? Yeah, so we wanted to have a quick look at what we are going to work with in this final exercise. Close everything down just so that we're a bit clearer. Close all these code examples down. Do take a look if you're ever stuck for how to do something. There are plenty of code examples in here, but also these are generally repeated in the book. So in exercises, in exercise 3, we have an LSOA map.py. I'm going to move into the exercises folder now just so I can run this and show you what it is. I'm going to do Streamlit run LSOA map.py. And what we get loading up is a relatively slow app. In this app, if I put this side by side a second, what it's doing is loading in a GeoJSON that is relatively big. You don't need to worry too much about what it's doing in between here. It's creating a data frame, it's creating some select boxes, that sort of thing. And then it is coming up with some projected daily demands. So basically looking at the population and the age of population and everything in these areas and going, right, well, based on the areas you selected, I think the daily demand for your clinic will be this. I'm not saying this is a good way to do anything. This is just an example app where you might have a larger data set and a user wanting to interact with a number of elements of it. And what you can see as well is it's still loading. It's chugging away in the background, also doing a long running calculation. So at the bottom of our page here, we have a complex calculation that is completely unrelated to the map. So why is this rerunning every time that the user is doing something to the map or changing the regions they've selected? Well, it shouldn't be. That's not much use to anyone. So we could maybe use something like an st fragment to make sure that that doesn't rerun when these are changing. We could also do something with our caching that we just learned about. So caching here will make sure that this data frame isn't reloading every single time just for the sake of it. The next thing we might want to do, instead of having our inter-arrival times, so we've got our average inter-arrival times being calculated here by this part of the app, we maybe want to pass that over to our app that we've been creating. So far, we've been allowing the user to define the inter-arrival times, but they don't have access to the data to define that. So instead, we'll pass that over to a different page of the app. How might we do that? Session state. So I'm going to give you half an hour now, maybe 40 minutes, to work through a few of these steps. We are going to get you to add an stcache decorator to the file load. We're going to get you to use an st.fragment decorator so that changing the parameters of the map and the select boxes and the generation of the map doesn't affect this calculation at the bottom of the page. The calculation is not a real calculation. It's just sitting there spinning its wheels for 10 seconds just to make you do something. So don't spend too much time trying to work out what that calculation is. What I then want you to do is add it as another page in your multi-page Des app from the previous exercise. So hopefully you will find it not too difficult to add it in as another additional page. And then if you get to it, have a go at saving the caller and patient inter-arrival times. So these figures here that it's spitting out currently in a Streamlit write statement, your average inter-arrival time, try getting it so that the user doesn't define those, that it's passed over via session state based on what they have input on this first page. So I don't think we've got any other questions. Jake, I'll respond to you separately after this about what is happening under the hood. But I'll share that with everyone. Hopefully I can't see any other questions that we haven't already answered here. So go and have a play with exercise 3. Just see how far you get. This stuff is getting a little bit more tricky. I've hopefully referred back to the relevant slides in each case, so do hop and have a look at the relevant slides for each section. Just work through it nice and gradually, and we'll come back and hopefully have a nice little fun bit to end off with, which is getting your app up and available on the web. So I will open up breakout rooms and see you in a bit. Hi everyone, hope you managed to have a bit of a go at that one. I'm aware that actually this fragment tripped up quite a few people, and that I think is my explanation of those may have caused some confusion. So the thing I would say about fragments, if you come to use those in your own apps, wrap the fragment around the thing that is changing. So for example, in this case, we wanted to wrap the fragment around the map and the inputs rather than the long running calculation. It feels naturally like you want to put it around the calculation because that's the bit that's taking the time. But in this case, actually, you want to tell the map to only update if the data inputs are changing. So it makes more sense to have it that way round in this case. You'll find you'll naturally get more used to fragments as you get more chance to play with them. Same with session state. I think not many of us managed to get onto session state in that exercise, but you will probably find it comes more naturally as you start to find examples where you need it in your own app. So just being aware that it's there is handy. So for the rest of today, we're going to talk a little bit about deployment onto the Streamlit Community Cloud and a little bit about other methods. I hope to do a more advanced deployment session or masterclass or provide some additional materials at some point in the future, particularly for those of you who are trying to deploy things locally, but at the same time, I think just getting to know your IT department and data engineers, etc., is probably your best bet there in a lot of cases. We probably won't also have time to go on, well, we definitely won't have time to do this as an exercise as a group, but I would really recommend if you've got a Streamlit app that you want to have a go at deploying, you can try and follow along when we get a little bit further through this section, or just come back to it at some point. The community cloud deployment is generally not too bad. You will find that most of it is just clicking buttons, signing up to things, and using our good friend GitHub. GitHub may be a little bit much for the end of the day. So we'll see how we go. But let's talk a little bit about deployment. So you've made your tool, first iteration of it, and now you really want to get it out there so other people can use it. There are a couple of key routes that you might be interested in for Streamlit. Streamlit app deployment. What we're going to focus on today is the Streamlit Community Cloud. There's also ST-Lite, which we'll talk about a little bit. This is a browser-based and almost entirely browser-based deployment of Python. There are additional cloud platforms. You might have heard of Heroku, Microsoft Azure, that sort of thing, that Streamlit can also be deployed to. And there are other enterprise platforms like Posit Cloud or Plotly-Enterprise that some of your organizations may have access to. So the thing about deployment is you need your code to be running somewhere. You need your code to generally be running on a server. So every time the user is doing a user input, it's something like running, changing an input, when it's rerunning a calculation, the server is doing that calculation. In general, it's not the user's browser doing the calculation. So you need a computer effectively sitting somewhere running the code for each user. A server is just a computer or system that is designed to provide resources or run code over some sort of network. That's a local network, that's over the internet. Any computer that's connected to an internet or the internet can be a server. You know, it doesn't just have to be big racks of servers like you might have seen in an organization, or anything can be a server. It will just vary in how good they are at the job and how exactly they go about doing it. It doesn't have to be a big server room. It can be any old computer. It could even be a microcomputer, depending on how much you need that computer to be able to do. Maybe it is also someone else's server running in its own little virtual machine on a cloud provider like Microsoft Azure. Now, Streamlit Community Cloud is an example of the same. It's a completely free hosting platform that for some apps will be a great option for getting them out there. If it's data that is not particularly sensitive, then Community Cloud is often the easiest option for deploying your Streamlit apps. If your app is hosted on GitHub, if you have put your Streamlit code onto a GitHub repository, it takes just a few clicks and your Streamlit app is then up and running for anyone to access. It gets its own URL that you can share with users, so anyone can access it from anywhere in the world. And this URL will stay the same. It's completely persistent. You can make it look nicer. It doesn't have to be, you know, a long and complex URL. There are a few limitations. Your little virtual computer sitting on Streamlit Community Cloud servers doesn't get much memory. So you're probably all finding your computers are starting to struggle with just a couple of gigabytes of RAM. Well, your Streamlit Community Cloud server will get even less. It only gets 1 gigabyte of RAM. For your more memory-hungry apps, or where you have a lot of people using that app simultaneously, that can start to cause problems. You can actually talk to Streamlit, and if it's a good use case, we have had examples even within our Pencord team of Streamlit going, this is a fantastic option, a fantastic app. We will give you more hosting for free, a better virtual machine for free. Other thing about these, if no one uses your app for a few days, it will go to sleep. And this just means that it might take a couple of minutes for the first user after that sleep period to have the app sort of wake up. They have to sit and wait for a couple of extra minutes. Other thing to note, all of these apps are hosted in the USA. There's no way you can get around this at present. That everything is just hosted on servers in the USA, which could be a problem depending on the kind of data you are trying to share. But I think it's worth always considering you might be able to publish more than you think. Just actually consider how sensitive the data you are publishing is, and talk to people in your organization about how sensitive the data is. So if it's the default parameters for a discrete event simulation or the way a pathway is organized, is that actually sensitive? Or is it going to cause a problem if someone knows that? What about travel time data at LSOA level? What about demand at LSOA level? Is that actually truly organizationally sensitive? Is it, it's not identifiable as long as you are aggregating at a higher enough level? So there are plenty of apps that can be published on the community cloud without problems. we've had a couple of HSMA tools that fall into that group. So, for example, the extra funding allocation inequality tool. This is one that has been created by one of our HSMA alumni, and it allows you to do quite complex calculations around the ways that additional funding should be created. But again, because it's all at LSOA level, it doesn't really cause any problems, or GP, a sort of aggregator GP level. Their organisation has been happy for all of this to go onto the community cloud. Same with our cardiac travel times app from HSMA 4. So this was an app that was looking, I've showed you this one before, travel times if you were to change or build additional cardiac sites for this particular kind of procedure. Again, there's nothing here that's stopping you from putting it up on Streamlit. And a couple of our previous HSMA projects that have done discrete event simulations. So for example, we had an ADHD pathway simulation several years ago now. But again, that was published on Community Cloud and there were no problems from their organization with doing that. So don't write off Community Cloud or from the get-go. Your organization just needs to kind of really be happy that you are not publishing things that are problematic. But it is always better to ask. Don't get yourself in trouble by publishing something you shouldn't have, but just, you know, take a moment, talk them through why it isn't a problem. What, you know, you will find, I'm sure you've all found, that organizations are very risk averse in this space, but we can also help potentially kind of explain why that isn't such a problem. So, thing to Dan's also just made a very good point. You could potentially as well, if you've got a discrete event simulation or something like that, you could default to parameter values that don't reflect your organization. Pathway might reflect your organization, but maybe the default weights or default lengths or default number of nurses, that sort of thing, maybe they don't reflect reality, and you provide some way for people to put in their own parameters, as you've been doing today. So, next thing about Streamlit Community Cloud, it needs to know what versions of packages you want. This will be noticed by Streamlit Community Cloud if you put them in a requirements.txt file, and it will use it to set up the correct environment for your app when you're building it. So you can be confident that it is using the same package files you've been using during development. Other thing to note as well is when you upload the app, and I'll demonstrate this in a minute, you get the option to define the version of Python it's going to use. When the app is deployed, you can't change this. You will have to go back, delete the app, redeploy it. So it's just one to keep in mind. Check your version of Python when you're kicking off. Throughout the whole HSMA web dev sessions, we've been using Python 3.11. Now, if you need to deploy locally, you probably, as I say, want to make friends with someone in IT or data engineering. At a bare minimum, you will need a computer that's always on and can always have a Python process running and is accessible on an internal network. They will probably have to do some work to make sure that certain ports are available so other people can access the running Streamlit app from a different computer. It's also not the most robust, but it might be enough for a bit of a proof of concept internally. But you will probably have to do some babysitting of it. And like I say, you'll need some help dealing with ports. So talk to your IT department if it's something that you know will have to be deployed internally only. A better next step would be Docker, which allows us to spin up sort of virtual containers, virtual computers that are a lot more robust, will spin themselves back up if they crash for any reason, that sort of thing. We'll wait until a masterclass for that, but just be aware that there will be options like that if you needed to deploy internally long term. Another fancy one as well, and an option I'm really fond of myself, is Pyodide. So Pyodide is a web-based version of Python. It runs Python code entirely within the user's browser. All you need a server to do is just hand out an HTML file that defines the code. It doesn't actually do any of the running anymore. The server does not need to be powerful. It just needs to basically hand out a bit of paper almost. The user's computer is then doing all the calculation, and also the data doesn't leave the user's browser. So anything they upload, any calculations they do are all contained within their own machine. So like I say, less server power is needed. It's the way we ran things like the HSMA Open Day, because we couldn't have 100 people simultaneously accessing an app on Streamlit Community Cloud. It wouldn't cope. But running it that way, all the server needs to do is hand out that bit of paper to each person that turns up. Their computers are doing the hard work. It is slower. Every time you load one of these, a number of packages need to be downloaded, and even the individual computations tend to be a lot slower than on a server, so anywhere between 5 and 20 times slower. That sounds like a lot. Depending on what you're doing, it can be. Other times it really doesn't make that much of a difference. Depends how quick it was to begin with. The other thing that is important to know is that it does depend on the power of the user's computer or their phone. So running certain things like a discrete event simulation on a phone can be really quite slow. Running it on a half decent laptop or even your average organizational laptop, not such a problem. So it's something to just sort of weigh up and try out. There's also a couple of limitations on packages that you can use. Don't worry too much about the ins and outs of that. It's enough to know that for now, SymPy, Plotly, Pandas, all of the standard ones that you probably want to work with are available and will work with this method of deployment. So that is all done within what's called the ST-Lite framework, and it doesn't take much modification to your existing Python code, your existing Streamlit code, to turn it into a deployed app. But I've put that in the book. We won't go through the details of that today. You can, in theory, take ST-Lite even further and use this to create a packaged up executable file. To be honest, I think you will get even more resistance from your organization for taking that approach. I don't think they will be particularly keen to let that through, let that run on people's computers. And you get back into that whole problem of people having different versions available, like sending around, a spreadsheet as a tool. Well, once you start deploying an executable in that way and emailing it around to people, you're back at square one, rather than sending them to a web address that has the most recent up-to-date version. But there may be some ways, again, if your organization is willing to work with you, maybe you could get it on a software center, that sort of thing. But I think more often than not, it's going to be more hassle than it's worth. It's not the easiest approach, but if it's the only option available to you, you might be interested in it. If you're lucky enough to be working in a really progressive organization, you might have access to POSIT Connect, Plotly Enterprise, or Snowflake. I would love to know if you do, because that, those are going to be almost the gold standard right now. They will make your life so much easier for deploying and maintaining apps. They give you things like control over users that can, user authentication, who you will allow to access the app. There are ways to do this within Streamlit, and Streamlit are trying to build in their own options as well. But by and large, it's a real pain. And things like Plotly Enterprise, POSIT Connect make this a lot easier. POSIT Connect and Enterprise actually are all about multi-language support as well. So if you've got something like POSIT Connect, you can deploy an R Shiny, you can deploy perhaps an automated Quarto report, and you can deploy a Streamlit, and you could deploy a Plotly Dash app. So they are fantastic things to have, but they are expensive, and a lot of organizations haven't yet invested in something like that. So, like I say, price often a big barrier for these kind of organizations, but there is a lot of potential efficiency savings. So in the long run, it might be something that your organization is interested in working towards having. POSIT in particular, via the NHS community, NHSR community, there are some links with POSIT, the organization. They make RStudio. They make, they are an organization that is willing potentially to work with NHS organizations to make pricing available that will work. But I haven't had direct contact with them myself. But maybe reach out via NHSR if this is something your organization might be willing to explore. If you do have access to this in your organization, I'd be really interested to hear. Please do pop it in the chat, either on Slack or in Zoom. It would be great to hear more about how your organization has used it and how valuable you found it or not. So what we're going to do, I'm going to give you a quick demo of uploading an app to the community cloud. What this is going to involve is putting our app into a new folder, adding requirements to that folder, requirements.txt file, publishing on that on GitHub, joining our GitHub account to Streamlit Community Cloud, and then enjoying the fruits of our labor and our published app. So I'm going to do this in a new VS Code window. First thing I'm going to do before I do anything else, I want to deploy, let's have a look, my nice Des app, the one that I was creating that we've demonstrated throughout the day, that is looking at the Des, the simulation, it's running the simulation, it's got a home page, etc., etc. For now, I'm just going to copy this out somewhere else. I'm going to put it in C, HSMA teaching. I'm just going to call this, well, let's just paste it in as it is. This might be your exercise folder, for example, the most recent one that you've just finished doing. I'm going to call this HSMA Des example deployed. Call it whatever you want. The main thing is now, I'm going to open up a new VS Code window. And I'm going to go File, Open Folder. I'm going to find where I've just copied that code, which I have put into C, in my case, HSMA teaching, and I'm going to open up that app. There we go. I'm going to trust the folder in this case. Yes, I trust the authors. So now you can see, rather than having all these multiple layers of things going on, we just have our init.py, our app, our Des classes, our logo, anything else we need. I'm going to right-click and choose New File. I'm not going to do that. I'm going to copy in from exercise 4, my requirements.txt. Copy that, right-click and copy, which they've moved in Windows 11. Right-click, paste. Control-V, paste. What you want to do is get that requirements.txt into the same level of folder as your main app here. So you can see in this file, all we've got is just a list of pandas, SymPy, matplotlib, Streamlit, etc., and the version numbers they are pinned to. This just makes sure that when we are deploying to Streamlit, it knows that it needs to install SymPy, which isn't on there by default. It will also install pandas. Well, pandas and NumPy tend to get installed by standard. Streamlit is also on there by standard, but it's better to actually specify versions. It will mean that your app is more likely to continue working. So that's all there. I'm now going to go to my source control. And I am going to, in this case, directly publish to GitHub. Now, if you've gone through the GitHub training a couple of weeks ago, you should have this publish to GitHub option available because you will have already linked your VS Code to GitHub. If not, there are more details in the slides that allow you to kind of go back through that process, do the deployment a bit more gradually, and work with that. So I'm going to deploy, in this case, to a public repository. And it's going to ask me what I want to include. It's going to hide that under my Zoom screen, my Zoom bar, so I can't actually see or do anything with that. So let's try that again. Right, so I want to deploy all of these things to my GitHub app, my GitHub repository. I'm going to click OK. And now I've successfully published to GitHub. If I were to go to GitHub, take a look at my account now. So I'm going to go to my repositories, clicking over on the right on my profile picture. You get a menu that allows you to do things like your repositories. So here we've got now my HSMA Des app example deployed. So that is now sitting on GitHub and Streamlit can access this. So if I now go to streamlit.io, so just streamlit.io, put that in the chat, you will be given the option to sign in or sign up. Now, most of you will need to go through sign up. Annoyingly, because I'm already signed up, it's jumped me straight to sign in, but there are details throughout that allow you to link your GitHub account with Streamlit. Now, when you're doing this, if I jump to the relevant bit, you'll be asked to sign up. You can either use GitHub itself, you can choose Google, or you can sign up using an organizational, using your work email address or your personal email address, whatever you fancy. Regardless of what you choose to sign in with here, there will be an additional step. When you first log in, you'll be presented with a screen very much like this, where it says Create App, and you will come up with being asked to connect to GitHub. Even if you first chose to continue with GitHub here, that just uses your GitHub username and the like to actually populate, or username, account, etc. You'll still need to connect to your GitHub account. What it will ask to do then is authorize Streamlit. So you will need to look at what it's asking for. It's basically asking to be able to read and write, have quite a reasonable amount of access to your public repositories. But you can, if you're happy with that, you can authorize Streamlit to be able to interact with that. At this point, I'll return to my Streamlit flow. So I've already got a Streamlit account, and I will choose Create App. I've then got told that I have an app, or I can choose that either I already have an app or I want to create an app from a template. I'm going to choose that I have an app. I'm going to head over to my GitHub account, and I'm going to choose, I'm going to copy in the URL. I'm going to paste that in here. It's telling me that this file doesn't exist. It's tried to pre-populate with streamlit app.py. That file doesn't exist, but if I click in here, it gives me a drop down of the different files that it could choose to be the initial file that it runs. So that's the one when every time we've been going in streamlit run, in my case, it's going to be app.py. That's the one that's got the st.page and st.navigation, and will move us around between the home page and the simulation page as required. Now, here we've got a URL. You can see it pre-populates it with this rather nasty long URL. I'm just going to change this myself to HSMA deploy this. Note that you can't use underscores, you can't use certain other things. You just need text, numbers, and hyphens. I'm going to click on Advanced Settings because it's important that we choose, in this case, Python 3.11, just so it behaves itself. That's what we've been developing with so far on our own machines, whether we're using Anaconda or if we've been using the Anaconda environment. And now I'm going to click Deploy. And it will think about this for a little while, and it will put our app in the oven. And I will show you in a minute, Dan's just pointed out as well, there's a really nice, simpler and quicker way to deploy this if you've been using GitHub throughout, like a good FOSS developer. So here we have not got our multi-page for some reason, but we won't worry about that.
I'm sorry to interrupt, Sammy. You linked it to homepage.py, not app.py.
Oh, thank you. Thank you very much. Let's see if I can change that. That's probably a nice chance to be able to fiddle with what we've got here. So what we've got, as you can see, we've got our app. We also get this option to manage our app. So when we click on this, as we are logged into our Streamlit account, we get some additional options. We get a nice little indicator here of all of the installs that have been taking place behind the scenes, things like the packages that we've specified. And then we can click on these three dots and have some additional settings. So hopefully, I don't think I can change this at this point, unfortunately. Well, that's a good chance for me to show you the other method of deployment. So now that I've deployed this app, I am going to go back to my Streamlit, my GitHub account here, not my GitHub account, my repository on my computer. I'm going to do terminal, new terminal. I'm going to choose my web dev environment because that hasn't loaded up by default. Open a new terminal so it's using the correct environment. You can see HSMA web dev here, and I'm just going to do Streamlit run.py. Now you can see this is loaded up with our beautiful color scheme, and on the far right at the top here we have this lovely deploy button. Now, because the app is already deployed onto GitHub, or it's already been uploaded onto GitHub, I can just click this lovely deploy now button. It will take me straight to my Streamlit account if I'm already logged into my Streamlit account. And at that point, I can do all of what we've just been doing. I can deploy the app. So it's pointing towards the correct repository by default. It's chosen the correct branch. This time it's chosen the correct file path. And let's try this HSMA deploy 2. Make sure I set my Python version and save. And now I'm going to deploy again. This time, hopefully, it will deploy the correct file. And the great thing is here, every single time you then make a change to your app and commit it to GitHub and push it to GitHub, follow that whole version control flow, your app on Streamlit will automatically update. Now you can use things like branches to make sure that you don't update on every single change, that maybe you want to fork a development branch and not fork, but maybe you want to make a development branch so that you have a development copy you can work on, or staying, or deploying only a clean copy. You can choose which branch you are deploying from when you're setting up that app to make sure that works. But now this app is available on Streamlit Community Cloud. That's how simple it is. You are now able to access this app, and we can run the simulation. You can all run the simulation, and that should load and work for all of you. Now, it might fall over if all of the remaining 83 of you do try and run that at once, but we'll see how that goes. But hopefully that just gives you a bit of a flavor of how to deploy to Community Cloud. You may run into a few problems. You may find, particularly with your requirements.txt, that that's something that you might have a few issues with. If you do change your requirements.txt, I would recommend clicking on this little Manage App button and choosing to reboot your app. It might just clear things out. It might force it to recreate the little virtual machine running on Community Cloud servers from scratch, so that actually you do have it's loaded in and reloaded all of the correct packages after you've made changes. But if I were to go and make a change on my app now, let's go to my home page and say, what do we want here? st.write. This is my update. I'm going to save that. I'm going to upload my homepage change to source control to GitHub. Added text. I'm going to choose my favorite, commit and push, using this little drop down, commit and push. You can see that's just going into my GitHub repository. If I were to load my GitHub repository, we would see that change, but let's see how long it takes to come through on here. So I'm going to reload the current page. This is my update. There we go. See, they're already up on the Community Cloud. It's read straight from GitHub and pulled in the new text that we've just created on our computer. So it's quick, it's nice and effective. This is a really good way to get your apps up to begin with. And if you have a bit of a chance, and if you think you might want to be using Streamlit in your project, I would recommend, when you have a moment, to have a go at deploying something that you've created over the last 2 weeks or 3 weeks of Streamlit. So as Dan points out as well, every time you reboot, it will kick out everyone that's using it, but hopefully that won't generally cause too many problems, especially while you're doing the initial development. So I'm going to call it a day there. I'm sorry we didn't get a chance to actually all go back into our groups and do a bit of deployment, but we'll maybe have a look at doing a bit of a if anyone's got any questions about deployment and would like some help, do give me a shout. There's also plenty in the Streamlit book about deployment, both to Community Cloud and also to the Streamlit, the serverless Streamlit method of deployment, doing that on GitHub pages. So definitely recommend having a go at Community Cloud. And if you're interested, have a go with serverless Streamlit. I don't think, do we have any other questions?
There was something about being deployed to Microsoft Azure. I posted a link in there if people want to do that. That's from Streamlit's own forum. So there's some good instructions there if you do want to do that. I mean, my personal advice would be, I think for most of the apps that you will be developing, the Community Cloud would probably be absolutely fine, because most of the time you're not really, as Sammy said, you're not really going to be posting up sensitive data, and the limitations, you're probably not going to run into them for most of you are likely to be developing apps that a few people are going to be using every now and then. They're not going to be sort of mass user apps. If you are going down that route, I think you then need to look at some of those other options. But my overall advice would be the Community Cloud, I think, would be fine for most of you, and it's easy as well, as long as you're using GitHub, which of course you all are.
Yeah, absolutely. It's a great motivation to get really comfortable with Git and GitHub, I'd say. You really will reap the benefits of putting in the time to get comfortable with GitHub when you get to the point of wanting to deploy apps on Streamlit. It really does make things so much easier and so much better. So that will hopefully, you will hopefully enjoy that. If you do deploy any apps, please do share. Would love to see what you managed to deploy. Pop that in in your Slack channels. It would be great to see what the end results of some of your coding journeys with Streamlit over the past few weeks. But we shall wrap up there, unless Dan, any other announcements or things we want to cover before, any reminders?
I'm going to be like a broken record. Please register your projects. please do that. It is vitally important. So please don't forget to register your projects, put them in the new project airlog, and we will deal with that for you. And just a reminder, Sammy said this morning, if you want to come along to the hackathon, please do sign up. Sign up for that in the spreadsheet. If we haven't, by the end of this week, got enough people interested in doing that, we will call that one off. But yeah, I can't think of anything else other than say, please register your projects.
Fantastic. And thanks, Dan. And next week, we will polish off the course with a bit of an adventure into Quarto and also reproducible output creation with Excel. Feels a bit of an odd one to end on, actually, after how long we've banged on about FOSS, but we do recognise that there are sometimes times that you just can't get away from Excel. And if it makes your organisation sit up and take notice of data science because you've populated an Excel file with an XGBoost model, then, well, it's the right way to go for now. So we will cover all that next week, and we'll also just wrap up a little bit, talk about some of the things we couldn't fit onto the course as well. I hope that'll be an interesting one, and have a bit of a chance to just kind of recap what your next steps will look like when you go onto your projects. But as Dan says, please start registering your projects. I know there's fantastic projects out there. We've had such good conversations, and I look forward to seeing you next week for the final session, the final official teaching session of phase 1. Thanks very much, everyone.